Καλημέρα, καλημέρα, καλημέρα. Θέλω να πιστεύω ότι μπορείτε και να μας ακούσετε αυτή τη στιγμή. Συγγνώμη για τη διακοπή. Good morning to everybody. Sorry for the inconvenience this morning. I really hope you can hear us now. We have a third-party sound console here that refused to cooperate. It is not our equipment, so there was nothing we could do about it. Let me know if you can hear us all right. Is it the sound okay? Well, good morning. Good morning to everyone. Good morning from Athens. Thank you for joining the live stream this morning. Hope we didn't have this little issue. I have Olga with me this morning. Olga, this year, she's back from London here in Athens, which is really, really great to have her around. I haven't seen her for more than a year, I believe.
More than 2 years, perhaps.
Wow, yeah. And over to Olga.
A very warm welcome from Athens. We are very happy to have you with us. I'm not sure if you can hear me. I hope you can hear me as well. As you may have already noticed, we've prepared an exciting event for you this year, and we will be very happy to welcome you on board live from Athens next year as well. So hope you enjoy our event, and we'll be here for any questions or any comments that you wish to share with us. So enjoy the show.
Yeah, just let's make sure that the sound is as it should. I get the feedback from here. Apparently we need to increase our input. Let's see. Can you hear us all right now? Is it okay? I think it's the...
I hope it's better now.
Yeah, let me know if you can hear us. While everybody's having their coffee break, we can still say good morning one more time to everybody. Let me double check for a second. Yes, I think we're okay. I think sound now it's as it should be, right? Yes, okay. We got the thumbs up from Nikos Pisanidis on the other room. We will stream to you again to see how things are going up here. Let's... good morning to everybody once again. For those who are joining the streaming right now. Again, apologies for the inconvenience this morning. We have a third-party sound console, which is not our equipment, and it failed to connect to the Mac. Apparently there is a known issue with the Rode console connecting to Mac. There is nothing we could do. We had to restart our streaming software and the console as well. Again, good morning to everybody. I hope everyone is connecting to this new stream at the moment. Please do comment and invite your friends. Please refresh, please let people know. We posted a message to let people know that we will do this. They have to refresh their stream on YouTube. It's now is live, and you should be able to hear us without any issues. We will try to give people time because we have like a 10 minutes coffee break anyway. So I believe hopefully they will figure out that they simply need to refresh their page. So YouTube gives them the new live streaming for them to click on. Olga, how was it COVID in the UK? Did you enjoy your time with Boris?
It was very exciting. So very exciting. Being locked inside, and then we gradually had different measures. It's like every now and then things were changing. I think it was the same all across the world. So much uncertainty and so many new things to learn. But now it seems like we're getting back to normal.
Well, let's see. Finger crossed, as they say. Last week it was InfoSec London, InfoSec Europe in London for that at Excel London basically. happening in person again, and apparently there were people going there, but they were not having the numbers that they used to have.
Yeah, I guess so. It seems that things are people are trying to do things, but it's not always the same, isn't it? I think it comes back to the uncertainty. So people don't really know how to handle the situation yet, or it's gonna be an ongoing thing.
Let's hope they won't end up, locking us in for winter again this year.
Oh no, I don't even want to think about it.
So yeah, welcome to anyone and those who are joining the stream again. Again, apologies for the streaming issues. We had an issue with the sound console, which is not our equipment, and this is the console right here. It had an issue, and we had to reboot. A reboot fixes almost everything, I suppose. We are during the coffee break at the moment, so there is enough time for you to go grab a coffee, join the stream, message your friends to join again the stream. Let me put the little video on and let us do some more checks from our side, and we'll be right back with you. Καλημέρα, καλημέρα, καλημέρα ξανά από μας, από την Αθήνα. Good morning to everyone from Athens. Good morning, good morning. I hope you're here without any issues at the moment and everything works exactly as it should. We have also posted the message regarding the CPE certificate. I hope everyone can see this. You need to go and sign your name and email address to this form. Once you do that, there will be a second form later on in the day. Those who sign both forms, they will qualify to receive the certificate of attendance. That means once you receive that document in 2-3 weeks' time, that means you can claim 10 CPEs for those who are collecting professional credits. Let me remove ourselves for a second from the screen so you can read this a lot better. Yeah.
It is more or less the same process as last year. So those of you who regularly join us will just follow the same process. For those of you who joined us for the first time this year, you'll see that it's a very simple form. We just need to confirm that you've attended the whole day. So that's why we've got two separate forms for you to complete. So once now, it's just your first attendance recording, if you wish. And later on this afternoon, you will just need to confirm that you're still here and you can get the full day CPEs for you.
Thank you, Olga. I hope everyone can see the message on the screen. We have a confirmation that you can see the message on the screen. Please take a few seconds to sign the particular form. I think the form also will be a copy-paste on Discord, so you don't have to guess the letters. I think Nikos is in the other room. He will also paste the link on our channel on Discord, so it is for you to simply copy-paste the URL. Please check Discord for the link. We will now return here so you can also see us. We are ready to move on with our next talk. Please stay tuned during the day. You have to sign the second form as well to qualify for the certificate of attendance. We have tales from the DevSecOps. Let's see. Enjoy the next talk.
Enjoy.
Hello people, I'm John Dorakis, security engineer at Scrooge. In this presentation we're going to talk about provisioning a CM with code and about the whole thing with the infrastructure as code trend and the workflows it suggests sometimes to the security teams. Basically, to introduce the concept of CM is the thing that might inform us if we're getting hacked and consists of 4 basic components. First of all, the search engine that stores and searches the logs and generally does the heavy lifting. The various data shippers and the other collectors that deliver the logs to the system. An engine that does log correlations depending on specific rules, exceptions. And finally, a system that alerts us on successful correlations in various ways, like emails or Slack or whatever. At Scrooge, we use Elastic CM with Kibana, Elastic Agents, and that kind of stuff. Our data sources vary from AWS to OpenLDAP, so it contains all kinds of things. Finally, we use a very small project, Praeco, which has alerts and command triggering. So here we deploy a CM completely from scratch, but in Kubernetes. At Scrooge, we use Kubernetes with a pretty standard open source setup, like Nginx Set Manager, with Let's Encrypt certificates, external DNS, generally that kind of stuff. Generally, we use heavily tested stuff that work well both on-premise and on cloud. So, to deploy the CM, we use an open source project called Blue Baron, created a while ago by a colleague and me. The repository consists of Terraform modules and examples that deploy Elasticsearch, Kibana, and the rest using Helm. The project is inspired from Red Baron, another Terraform repo for offensive cloud infrastructure, such as C2 systems, redirectors, payload servers, and such. And it works on all kinds of Kubernetes clusters, like from Minikube to cloud managed services, anything goes. This is how the empty bed where everything will get deployed looks like. And this is how the complete picture looks like, and the deployed services that get there. So all these services get a TLS-enabled endpoint for us to reach and consume, and also their interconnections between them are all TLS-enabled. Finally, this way we end up with a default CM deployment that has alerting, command triggering, dashboards, and exotic load connection. So now George will explain to you how to configure the Elastic Stack as code.
Hi, this is George. I'm a security engineer at Scrooge, and we're going to talk about configuring the Elastic Stack as code. Logs. Logs are important. They are generated by services and applications. These logs provide information for what is happening right now, and this kind of information needs to be transformed to provide a value to us or an administrator. Bits and fluentd, data shippers, and data collectors are used to gather and push these logs. These sets of data are sent to Elastic indices or indexes. An index has a structure predefined by an index template, and the incoming data are enforced to match the structure. The incoming data might need some transformations, and this is achieved by ingest pipelines in steps using processors. A processor might be a simple addition of a field, or a deletion, or a modification, or a calculation. Our indexes can include data retention policies in defined phases. The phases are hot, warm, cold, and then deletion. Finally, snapshots are taken regularly as daily backups, and all of these components, of course, can be configured from Kibana, but it has to be done every time a new setup is deployed. So, we create a structured, portable, and auditable way to maintain these configurations as code and do it only once. Alright, the same applies for users, roles, and privileges, for the cluster and Kibana dashboards. Roles have specific and can have multiple privileges. A user might also hold multiple roles to perform each action. Everything can be configured, of course, by clicking and dragging and dropping and huffing from Kibana, but if you do it as code, you do it only once, and you have the ability to maintain it, to review it, and to monitor any change. The Elastic Stack has multiple moving parts, and each deployment includes organization specifics. So you have to set up something according to each organization's needs. These questions might look familiar to you. Tracking, rolling back changes, retaining, backing up logs, managing users, adding, removing, whatever. Clicking around Kibana can be from tedious to impossible. So we try to solve all of them with the as code approach. Now for a real example. This is an actual module created to define a composable index template, or a legacy one. You can set up its type, name, and policy, the alias, the intervals, and the shards and patterns shown on Kibana dashboards, even the pipeline and the mappings of special fields, such as an IP address. Some fields, such as the final pipeline and the static template mappings, are of course optional. This way you can configure and create a new template only as code. Down below you can find an open source Terraform provider for these configurations from Phil Baker, and we created modules based on this provider. The snapshot module. The snapshot module defines the cron format schedule, the snapshot name, where to store the backup, and the indices that need to be backed up. The index lifecycle management module defines, or ILM, defines the phases, the hot, warm, cold, and deletion, alongside the max size and the days passed for each phase. That means if we reach a threshold of gigabytes or a date, we can move on to the next phase. The ILM module might need to wait for a snapshot. Pipeline. The pipeline module specifies some basic fields such as name and description. The type is a custom field because our module can accept a JSON structure or an inline penny script as a processor. Some new lines and double slashes need escaping to work their magic with both processors, and it's not the most beautiful thing, I know, but at the moment it does the job and it does it pretty well. Finally, the actual processor. This is the heart of the pipeline. This processor uses both a JSON and a penny script in two separate files for cleaner code and better reviews probably. We could just output a whole script in one line, but this is more readable. This processor, for example, includes a grok pattern that maps opened-up log fields to ECS and a penny script that adds and calculates a new field if the event was captured in company's off hours. So, with this script, you can catch actors if they work at midnight. Thank you. Now is Kiki.
Hello, I'm Kiki, and I work as a security engineer at Sprout. And in this part, I'm going to explain to you how we manage to keep Elastic CM rules, exceptions, and lists as code. Let me give you an example to explain how exactly they work. Let's say that we want to create a rule to catch any DNS that is not to Cloudflare. And the exception container contains two items, so as not to trigger the rule only when a Chromecast device is going to Google DNS, and also when the traffic is coming from guest Wi-Fi network. The IPs of Chromecast devices are badged as values in the list item. Structure of Elastic rules is as defined by official repo of Elastic detection rules. Rules are expressed as TOML files, describing the rule, giving some necessary properties such as the name of the rule, a time range from when to search indices, for example file read and packet read, and the type of the rule that can be either a query, a threshold rule, or an EQL rule. Here, a very interesting thing is the reference of exception containers. Keep in mind that in this way we cannot create exceptions or lists with this syntax. So, the way to overcome this is by creating exceptions as defined by Elastic Exception API, which can be expressed as YAML files. The YAML file contains the part of the exception container in which simply we describe the items, where every entry does have a log field and a value or a list to get it checked against. Finishing the as code part, the lists don't innovate, they are defined by Elastic Exception API and expressed as YAML files, likewise the exceptions. The structure of a list consists of list containers and items. A list container describes the list items actually, and the list items include the values of the container. That is the IPs of the Chromecast devices in the example above. Good to mention that the interconnection between the item container and lists happen through directory structures. As anyone could imagine, maintaining such a complex structure for each CM rule is not a piece of cake. That's why infrastructure is one way. So every CM rule is implemented by a Terraform provider, abstracted by a repository template that manages the YAML and TOML files of rules, exceptions, and items. Hence, the only thing you have to do is to write your own TOML file and YAML file. All this code is open source, managed with GitHub workflows for automatic Terraform plan and apply, integrating with the official Elastic Detection Rules repository. Git is of course our best friend to review change management. This way, no one is able to make a change on the repository without being firstly reviewed by the teammates. Thank you very much. Feel free to ask any question.
Hello Athens, welcome to hijacking Voodoo presentation. My name is Nikos Vourdas. I'm glad to be here. Thank you for the invitation. I hope to don't disappoint you. For the next 20 minutes I will talk about hijacking persistence. Who am I? My community name is Nick Vourd or NCV. My friends call me Nick Vourd. It's a Counter-Strike name. I'm cybersecurity consultant at Ernst & Young Greece. I have OCP, OSWP, and CRTO. The last one is my favorite. I was speaker at DevSecOn Chapter Greece, BSides Tirana, and Cyprus. I'm community supporter of cloudbridge.io. Furthermore, I'm author of ComHunter Root and Tools. I am member of Bit Warriors CTF team. Shout out to my guys. And this is my Twitter. If you want any collab, please send me a DM. Probably I will answer you. I'm not a diva. Today we will speak about what is COM, and we'll explain COM more deeply. And we'll show we'll show an action about the COM Hunter tool. COM, what is COM? Okay, the full name of COM is a component object model. It is a Windows built-in software interface. COM is useful for intercommunication of foreign applications, aims one application functionality to another, and supports a large variety of different programming languages in order to avoid any conflict or troubleshooting of communication of different applications in written in different languages. Here is a simple example of using COM. We have a Word document and we want to empty a worksheet from Excel file. For this action, COM works for you behind the scenes. And here we have the worksheet in the document. Okay, let's move on. COM relationship. Okay. We have an application A and application B. Application A maybe is the Word document. The application B maybe is the Excel document for the previous example. The application A is the COM client. The application B is the COM server. The application A requests foreign object from application B, and the application B returns its functionality. Any component of application B has a unique identifier named class ID. Okay. Each component is identified via class ID, which is a pseudo-randomly globally unique identifier. Each COM component exposes functionality via one or more interfaces, identified the interface IDs. A COM class is an implementation of one or more interfaces represented by their class IDs or programmatic identifiers. Prog ID. This is an example of class ID in probably in your system. The machines, the local machines COM objects are in Hive key local machine registry software classes path, and users COM objects located in Hive key current user registry software classes path. Probably you know that. Okay. The Hive key class root is the merge of Hive key local machine and Hive key current user registry. But we have something very interesting here. If we have the same entry in the local machine registry and the in the current user registry, the entry of current user registry comes first of local machine registry. More specifically, if an attacker has an entry in current user registry with a malicious DLL, this entry will run first of local machine registry entry. Okay. Last but not least, about COM relationships, the local server key represents the full path to an executable implementation. The in-proc server 32 key represents the full path to a dynamic link library implementation. Okay, this is an example of class ID, probably in your system again. This is from Microsoft Teams. You can see in proc server 32 key, and this is the DLL file. As we said, in proc server 32 supports only DLL files. COM Hunter. Okay, COM Hunter is 40.8 .NET Framework application, a C# tool about COM hijacking persistence. Author, okay, it's me. And code review by Dimitris Tsikopoulos. I want to say special thanks to Dimitris Tsikopoulos, my ex-co-working from 12sec. You are a teacher for me. Thanks for any advice, tips about the code, the format, the optimization. And I want to announce that me and Dimitris and me, we will release more tools in the future. The current version of COM Hunter is 1.1.5, and this is the ASCII art of COM Hunter. Probably you will see that this is the wrong version because we took the picture from the first version. Some useful things about COM Hunter. Finds out entry valid class ID in the victim machine. Finds out valid class IDs via task scheduler. Finds out if someone already used any of those valid class IDs in order to do COM persistent. This is a defense feature. It supports local server 32 and proc server 32, as we said before about the exent DLL. Finds out if someone already used any valid class ID via task scheduler in order to do COM persistence. Tries to do automatically COM hijacking persistence with general valid class ID. Tries to do automatically COM hijacking persistence via task scheduler. And tries to use tree task key in order to refer to a different component. Okay, let's see how COM Hunter works in action. Here is RC2. I use Cobalt Strike. Okay, we have access on victim machine. We don't care how we gained this access. Okay. Okay. Let's try to upgrade interactive cell. Okay. Here we are. First of all, we need to upload evil DLL on Victis machine. Okay, we will use it soon. Let's execute comhunter on memory. Okay, let's do this for the full screen. Here is the full menu of comhunter. As we said before, we have two modes, search and persist. The search mode has four methods. The persist mode has three methods. Okay, let's use comhunter to find a useful class ID without using any tool from ccTernal suite like procmon. Okay, as we can see, comhunter found those class IDs. Furthermore, it's very interesting if you use comhunter in a system which has pre-installed some other application like Chrome or Firefox browser. comhunter will find them and will try to find any useful class ID, as you can see. Okay, back to our example. Okay, we'll use this class ID because it's very promising. Persist mode, general method. Here is our class ID, and this is our level DLL. Okay, comhunter says that we have persistence in the victim machines. Let's restart the machine. Okay, we don't need this. Okay, when the machine will power on, the user will sign in. Will gain a new beacon. As you can see, we have persistence under DLL host process. Okay, let's go from the defense side. Suppose you are a threat hunter. Okay, and you want to use comhunter. You can see that the com hunter found that someone used this have used this class ID, and someone has persistence on your system. Okay, let's go here. Okay, and now we'll use it again. Nothing suspect found here. Your system appeared to be com persistent free. Okay, back to Cobalt. We can see that we remove the evil DLL from registry, but the beacon still works. Let's use it again to do another persistence. Okay, full screen. Okay, let's use the search mode get task. Okay, Commander found a valid class ID via task scheduler. This is very promising. Let's use this for persist. For task scheduler, we don't need to add the class ID. It do it automatically. Okay. Commander says that com persistent in this system. Okay. Let's restart the system again, but no need to restart the system. Go back and try to sign out. Okay. And sign in again. They'll be stop. But now we had a persistent under the process DLL host. Now we have a persistent under the task scheduler. Okay, let's suppose that the user want to sign out again. Beacon stopped, as you can see. Doesn't work. The user will sign in again. A new beacon appeared. Every time that the user will sign out and will sign in, we'll take a new beacon, and the old one will stop. Okay, let's go from the defense side. Okay, find task scheduler. Okay, sorry. Someone used a scheduler and this class ID to do com persistence. So back again. to registry in order to remove it. Okay, as you can see, this is our reveal DLL. Let's remove it. But the beacon works. Okay, this is the Com Hunter. Thank you for your attention. I hope you like it. And last but not least, it is what it is, boys.
Today, we're going to talk about lessons learned automating the incident lifecycle within the context of SOC. But first, I want to make a quick introduction. My name is Alexander Sino. I'm the head of the Inviso Fusion Center operations. I have some experience building security operations centers out in the Middle East. Previously, I used to work for the largest MSSP in the world, known as Dell SecureWorks, as a senior intrusion analyst. And before that, I was in the United States military as a fire support specialist. And I would like to also introduce my colleague who's a co-presenter with me today, Walter Stinkins.
Thank you, Alex. I'll also quickly introduce myself. My name is Walter Stinkins. I've been working at Inviso for 4 years. I have a background as a DevOps engineer and in cloud security as a DevOps engineer. Big part of your work is automating stuff, and that's also what I've been doing as the SOC engineering team lead at Inviso.
All right, thank you, Walter. Just before we dive into the cool stuff like the automations and those sort of things, we should break down the perspective of why automation is so important. Now, when you look at the traditional SOC, each analyst, they have about 20 minutes per security event, or 20 minutes to handle a security event, right? Now, those numbers actually add up quite a bit. Most of the time, a SOC analyst can actually handle a maximum of 25 security events per day. And the big problem is, okay, we have a huge lack of personnel worldwide. So how do we deal with that? And we know that from our experiences that automation is key. Now, we took a 7-day time span and we calculated that we ingested 647 security events. And if you use the math that we displayed above, that would take about 26 analysts to handle all of that. So you do the math on what type of a cost that is. And now just for you to have 24/7 alone, without factoring in all the security events, you need about 12 analysts. Now, when we saw those numbers, we decided immediately to start automating and start assisting the analysts with automations. The first thing that we saw is that our automations actually decreased the analytical workload by 97.42%. Of 5,790 alerts that we took in that time period, only 145 were manually analyzed in 7 days by the SOC. This reduced costs down to 1,483 euros as opposed to 59,251. So the math is there, and it makes a lot of sense to handle it this way. Now to explain a little bit about why this is important and why it's so effective, let's look at the traditional SOC. So in a traditional SOC, this is what you would have. You would have isolated components, none of them talking to each other, none of them working with each other. So everything in a different silo, which increases the number of clicks for an analyst to resolve an incident to find the information that they need significantly. And it makes them less apt to going into all those individual devices at the end of the day in order to find the information that they need. So what do we do to solve that? We use a security orchestration and automated response platform called XOR, and we do a lot of development on top of it. And that way we can actually work with all the different components without actually having to go to those platforms. So we assemble all of the data into one spot where XOR will become the central nervous system of your entire security operations center, and all of the capabilities that are available for your analysts will be built into one platform. So isolating machines, running antivirus scans, resetting passwords, revoking sessions, making a phone call, getting information on what ports are open on a specific device, getting a reputational analysis from VirusTotal from your threat intelligence feeds, all in one place for the analyst and just completely handled by automation and presented to them, so that it actually takes the analyst significantly less time to handle an incident because they have a hell of a lot more context to work with. So these are all important factors. So not only just automating from the entire events, but also reducing the amount of time and effort that it takes an analyst to make a conclusion on a particular security event. Now, just to go through a bit about the incident lifecycle and the way that we manage it here at Inviso. So we built something up at a high level. The first step is triaging. So we build our integrations into the XOR platform. We only pull in from the security end products, such as the EDR and the SIM. And what we do, when those are ingested, we immediately start enriching those events with other various types of data. So, for example, we'll take all of the IP addresses, all of the hashes, all of the user accounts, the hosts, and we'll start converting those into indicators of interest. Those indicators of interest are actually stored in a panel for the analyst for them to be able to see all the relevant information that they need. Now, in a lot of cases, we even store data inside of the indicators themselves. So when we extract a phishing email, for example, that entire phishing email sample is actually laid out for the analyst inside of XOR. So no need to jump all the way into another tool just to see the layout of a phishing email. So taking it maybe 1 minute just to analyze a phishing event now, as opposed to 20 or 30 minutes per each phishing event, because you got to jump into, 1 or 2 different platforms to do that. Now, the second step is the incident management portion, right? This is where you classify events. This is where you decide how you want to notify people. This is where you want to decide if this should go to an analyst right now. And it does a hell of a lot of filtering. And then it goes into the analysis phase. The analysis phase, we try to do as much automation as possible without adding additional risk onto our customer base or into any of the customer environments. So we don't automate where it's not practical and not wise to do so. Now, basically, a lot of the full automations that we do are checklists that analysts would do anyway, so they're manual steps that we fully automate. One great example is called the access anomaly classification, which we've built. And from that, we're able to fully automate the analysis of an impossible travel activity, and we can do it significantly faster than a human being. And most times, it's either something interesting or a compromised account that comes in. So when that is done, we then notify the customer through ticketing, through phone calls, through other various methods. And then we determine, do we need to destroy the actor now? Is there something in here that we need to do? So again, do we want to revoke a session? Do we want to isolate a machine? And how do we give those tools to a SOC analyst so that they can start taking action now? And these components is what makes a traditional SOC, or it's the difference between a traditional SOC and a future SOC, which is built on orchestration and automation. And those are very, very key elements. Now from here, I'm going to hand it back over to Wouter, who's going to talk a little bit about SOAR development.
Okay, thank you, Alexander. As Alex said, I'm going to dive in a bit deeper in how to do the SOAR development. At Enviso, we've been doing using XOR for more than 3 years now, and we're currently on our 3rd generation of the automation stack. We use Cortex XOR as an automation platform, and there you have 2 concepts to actually create your automations. One is playbooks, which is drag and drop programming, so you can actually define your complete automated workflow without writing a single line of code. And you have automations. There you can actually host your own Python code and do everything in there. Our generation 1 and generation 2 playbooks and automation stack, we actually had the principle to do everything within playbooks. Why? Because we wanted our engineers to be able to create those playbooks without needing to know Python. But from experience, we've learned this had some disadvantages, mainly performance. Here you can see a table with how long it would take for us to only do enrichment with playbooks in our generation 2 and our generation 3. And by doing as much as possible actually in Python code, we have improved the performance by almost 100%, which is, from a performance perspective, insane to do it like that. Currently, running our entire playbooks can be done at least under 1 minute, but we'll show you that at the demo at the end of the presentation. One of the consequences of actually doing as much as possible in code is that, it becomes a development project. And this also means that you have to implement some of the principles you would do when doing development. With my background as a DevOps engineer, I did a lot of these things. So the things we actually implemented is things like test-driven development, deployment pipelines, and all of these things. And one of the important things that we implemented to structurize actually all of our development effort is we started using the Scrum methodology. Scrum is actually an agile development methodology which allows you to structure your development efforts. In the beginning, when we started using XOR, we were just 2 guys developing playbooks on our production environment, and the requirements weren't clear. We had daily calls with the SOC manager, Alexander, and we were just implementing stuff, and we were just going. When you do this with 2 people, it's kind of manageable, but now we've grown our team into 6 SOAR engineers who are dedicated, who just write automations the entire time. Well, if you grow your team, you need a better methodology. With Scrum, Scrum actually requires you to first define all of the requirements for development as user stories. Everything needs to be clear what you need to develop. And once that's clear, you need to plan it. And the nice thing about Scrum is you can incrementally improve all of your processes. At the end of each Scrum sprint, within Scrum, you use a sprint of 2 weeks where you plan all of your development tasks. At the end of the sprint, you do a retrospective meeting where you actually reflect on the previous sprint to see, okay, what went well, what didn't went well, and what went better. We've been doing this for almost a year now, and you really see that we have been able to produce much more. We have been able to do a planning because in the beginning it was impossible for us to commit to our customers, okay, this is when your feature request will be delivered. That's something we can actually do now because we have an insight on how many development tasks can we actually do within one sprint? And also, when you do development, some other things actually are also really important. First of all, put everything into version control to make sure that everybody's working on the same code base. It's a very important one. Don't develop on production. You would think that's logical, but it still happens. We have a development, testing, QA, and production server. And we use our version control to move everything between those servers. All of our code is on GitHub. We use pull requests between different branches. Those pull requests need to be reviewed by somebody else who developed it, and all of those things. So when you start doing this, treat it as a development project. Implement the same principles as you would when developing software, basically. That's a very important one. So now to the interesting part, we're going to show you a demo. The scenario of the demo is first we're going to show you the end user perspective. The scenario is the CEO opens a malicious document on his laptop. And first we will show you the end user perspective to show you how long does it take for our automated remediation actions to be applied. And then we will show you how this all looks in XOR and how this exactly works. First we'll show you the end user perspective. This is the laptop of the CEO. We're going to show you exactly how long it takes. So let's start the stopwatch and execute the malicious document. We have Cortex XDR installed as an EDR tool, and after 39 seconds, it has already detected that something malicious has happened on the laptop. This alert will now be ingested into XOR. And our analysis playbooks will determine that, the threat is actually, the malicious document has been allowed to run, and it would automatically execute a vscan. So here you can see after 2 minutes after the alert has been generated, an a vscan has already been executed. The second remediation action that will be executed is a machine isolation. This is a semi-automated process which requires an approval from a senior analyst. So depending, of course, on how long the senior analyst takes to approve it, the machine will be isolated. So here you can see that after, in total 4 minutes, the threat has been detected, remediation action have been taken, and the threat has been contained. So how does this look like in XOR? Here you can see the XOR interface. And this is one of the dashboards. This is actually the dashboard that the analyst looks at every day. So if a new incident comes in, it will show up in this dashboard. XOR pulls alerts every minute, so we can take up to 1 minute before the alert is actually in our SOAR platform. So let's refresh this dashboard until the alert is there. Okay, there it is. This is the alert. Let's look at the playbooks that are being executed. It's already on the analysis playbook. Okay, now it's already on the notification playbook. And because this is the laptop of the CEO, which is defined as a critical asset, a different escalation path is actually followed. So our analyst will get a phone call because this is a critical alert.
Security alert from the NBSO Security Operations Center. This is a severity alert for wildfire malware, laptop CEO. Press 1 at any time to acknowledge this alert. To hear more details, please press 2. Thank you for acknowledging this alert.
So that's actually the call that our senior intrusion analyst will get because this is a critical severity alert. And this is a call chain that, if somebody doesn't acknowledge it, it will go to the next person. So now we can already see all of the remediation actions actually have been executed. We'll see how this looks like. Maybe first of all, I'll show you the interface itself. This is the interface of XOR. What you can see here is on the left, you can see all of the case details, the severity. Okay, it is a critical asset. It's not aggregated. The incident is, the outcome is allowed, which means that the threat has not been blocked. Here you can see the investigation data, so what the result of the analysis playbooks were. So here it says the threats were detected, but they were not all contained. Here you can see all of the indicators which are actually in the alert, in the incident. So all of the hashes, the sample, which user account, which host, all of these things. Here you can see the actual malicious document that got executed. And we also we ingest alerts from different scenes, and we present a unified interface, just one layout to the analyst. That doesn't matter which source product actually the alert generated. So in the remediation tab, here you can see all of the available remediation actions. Here is a list of the ones that have actually been executed. So here you can see, okay, a scan is pending, and isolation, that's pending approval. So this actually requires approval from a senior analyst. So what they need to do is first click the load button to see the approvals. Then they have to approve it. And then submit the approval. Here you can see, okay, the status, approval status is approved. And now it's waiting to be executed. And this actually runs on a job on the background. So that, okay, here you can already see that the machine has been isolated. So this is actually how this looks like in XOR. XOR allows you to completely customize the interface, which is really nice. This is a completely custom tab that we created ourselves. And with the automations on the background, you can actually run all of the Python code you want. So it's a very flexible platform, and this has allowed us to actually automate as much as possible in our SOC. Okay, so that was the demo. Would like to thank you all for viewing this presentation. If you have any questions, you can find us on LinkedIn. Well, hopefully you guys found it very interesting.
Hello everyone, thank you for joining this presentation. Welcome back to BSides Athens. My name is Leo, and today we're going to talk about open source intelligence, or OSINT. First off, some words about myself. I've been around in the industry for a bit over 6 years. I'm a security consultant and researcher. In the past, I've worked for companies like F-Secure, which was once called MWR and is now known as WithSecure, and NSO Group, which I'm pretty sure you all know. At the moment, however, I'm serving my country in the Hellenic Army's Cyber Defense Department, and you can find me on Twitter, GitHub, and all the things as LA Ripping. Today, I want to talk about an OSINT trick, which is one of my favorites. It is a known one, so don't expect any novel techniques or 0 days. And it's extremely easy and surprisingly effective for its purpose. We'll refer to it as contact sync. First, we'll see what it is and why we need it. Then, we'll go over the challenges of creating fake accounts or sock puppets, specifically phone-backed ones, which is a pain, depending on where you live in. Then we'll look at operational security considerations, or OPSEC, and what automation capabilities we have, or rather, what are the limitations. And we'll summarize with an evaluation of this technique, its pros and cons, compared to other tricks. Okay, imagine you walk up to your phone to realize you've missed a call and the number doesn't look familiar, so naturally you want to see if it's something important or not, to maybe call it back. Maybe it's your boss, maybe you've won an all-exclusive trip to the Greek islands, it could happen, right? Who knows? This is a typical OSINT scenario, where we start with an unknown phone number and want to get more intel about it. Something you might also see mentioned as an enrichment process. This problem can, of course, be tackled with many ways. We can see some of them in this excellent diagram from Intel Techniques, a great source of such diagrams, which essentially presents the OSINT landscape for this scenario. The path we'll follow is also covered, and it's the highlighted one. It involves a mobile operating system, a smartphone, and your contacts, your address book, as we can see. But we'll get to it in detail in the next slide. So let's see what our solution looks like. We'll start with a target number. We'll need any smartphone to add this number to our contacts. And then, using social media and instant messaging applications, we will upload this address book to Find Friends. That might take restarting the app, rebooting the device, or just refreshing the main screen, and boom, we get some new data for the target, typically a name and a picture, sometimes also the last active status, and that's just from one application, one service, as we'll refer to them. The cool thing here is that you can do the same thing with multiple apps and get more data, a different pick, a new name, or even different types of data altogether to slowly enrich your target. Awesome. How do we start? First, you guessed it, we need a smartphone. But why not use a virtual machine or an emulator, you might ask? The challenge with these is that to even install the apps of interest, sometimes we'll need to hide the emulation environment or evade root detection routines. And this can get complicated, with lots of custom mitigations employed by these apps to prevent abuse. This whole topic is massive in bibliography, and at the end of the day, yes, the reverser always wins, but overall it's pretty time consuming, so it's best if we can avoid this trouble altogether. And though the reason an emulator might not be the best idea is that it's trickier to simulate telco functionality, the phone part of the smartphone. For instance, we cannot insert a SIM, we cannot accept SMS messages for verification codes, so it's just easier to use a smartphone. Then we'll need, of course, a SIM card to create our sock puppet account, which we'll be searching target numbers from. In some countries, this is fairly simple, as you don't need to provide any ID to activate SIM cards. In Cyprus, for instance, you can just fetch a dozen of SIM cards from your local mini market, and then you're good to go, no questions asked. In other countries, though, like Greece, you need to provide a whole lot of personal info to get yourself a number in the name of national security. All right. Say we have no problem with that. The first obvious place to get this new SIM card is the local telco provider branch. Unfortunately, this solution isn't really good because it's just too expensive. I found out that for all prepaid plans, you need to first top up this number that you're going to use, which is at least 12 euros for the first charge. And that's a hefty price to conduct any large-scale operations. It just doesn't scale up. So this solution was abandoned. Note, however, that you can also go shopping in dodgier places and get your hands on dirty SIM cards without really providing any details or paying anything, so long as you know what you're doing, and be prepared to get scammed. Like I was, as the SIM cards that I obtained through this method were expired, and very smartly restamped as brand new. What about these promotional offers on subway stations? These youngsters selling free numbers loaded with data plans? Nope, that doesn't work either. As it turns out, they're not really free and actually need the same pricey first charge like the install ones. Now, someone might suggest using an online service like Twilio to set up, to sign up, get some phone numbers, receive the registration OTPs in them, and get cracking with the applications. What's wrong with this? First, you'll bump into this chicken and egg problem, as to verify yourself on Twilio, for instance, you need to first provide another number, your real number. And the whole point is to just hide this real number, right? What's worse is that even if we decide to provide this real number, we'll soon find out that we can't really use it to register on applications, as they somehow detect this is not a real number I've just used, and the SMS message for the registration just never comes in. So that failed too. Next, I tried a foreign number, kindly sponsored by a close friend, but that also failed, as apparently it's a pretty common requirement globally to frequently top up your balance, or it's just deactivated altogether. So another thing to keep in mind for any OSINT operations is that we'll need to actively maintain any sock puppets we create. So finally, disappointed as I was under the CFP time pressure, I decided to get back to the shop. But right before I gave up and paid for these hefty new SIM cards, a very helpful employee actually told me, hey, why don't you just sign up now and top them up later? We'll activate this right now. And I was surprised to hear that this is actually an option. So that actually worked. I just obtained a new SIM card without paying absolutely anything other than my personal data, of course. And the final step is to choose the applications we want to use to insert the target number within. And for this, we can, let's say, categorize the target applications in four main categories. First, on the top row, we have the big social media applications. On the second row, on the left, we can see the big instant messaging apps like WhatsApp, Viber, and Facebook's Messenger. On the right, though, we have the security and privacy-focusing instant messaging apps. Telegram, Signal are good examples. And finally, on this last row, we can see some applications that are critical for specific regions. For instance, vKontakte is pretty big on Russia. WeChat is the de facto chat application in China, and Line is also very, very popular in Japan. Alright, now that we have everything set up, let's see how this trick looks like. We'll use Telegram for demonstration. First, we can see that we've registered in Telegram with our Sockpuppet account. We don't have any contacts yet. Let's go ahead and create one. We'll use a question mark for our target account. We'll paste the number that we want to get more intel about. Save it, and then get back to Telegram, where we can see that immediately we have someone that we can add as a friend, and we get some interesting info. We get the username, we get the picture, of course, and this bio field. Right, this is manual effort. How could we possibly automate this? What if we want to script this? There are multiple solutions. As we discussed, we can just load the application in an emulator and maybe script this using testing frameworks to launch the app, do the lookup, and then parse the results. Or if there is a web client available for our application, we can just reverse engineer this and use DevTools, for instance, to examine the flow and then scrape any UE elements. Alternatively, and this is the most effective solution, we can just reverse engineer the mobile clients for our applications. But again, you might ask, what about these services that promise social media information about target users? Services like SyncMe, that'sthem.com, or People. Unfortunately, they don't really work, as they're based on something that's automated and easily accessible, aka easily abused. And this sort of functionality, like Facebook's graph, is eventually stopped. Okay, so what can we do to defend ourselves from this trick? How can we prevent users from getting our personal info through this, through the apps we use? The solution is to check our settings and mind the defaults. Unfortunately, there is no silver bullet. We need a per application solution. This also takes some digging, unfortunately. In Telegram, for instance, the right knob to change is under phone number, and we need to explicitly change it to this value, to nobody, and only then the latter radio option pops up, allowing us to select my contacts and make our number uncontact syncable. Let's talk about OPSEC. The first thing we need to keep in mind is that should we decide to use a sock puppet and reuse it all over the place, then this account might start getting too much heat. And interesting correlations might come up behind the scenes in the graphs that all services use. To avoid this, it's best to just create a new account every now and then, or use a different sock puppet per service. Similarly, reusing the same device for multiple operations might introduce some risk, this time on our end, as the hot address book of this same smartphone, should it be compromised or stolen, could end up profiling our operations. So the consideration here is to remember to clean the device periodically. And finally, the dreaded "you might know" bubble popping up on the target send, revealing our account and operations. This is the worst possible side effect of this contact sync trick, but fortunately it's pretty rare. The solution is to just avoid repetition where possible, as typically this correlation might take more than one search. And the good thing with this trick that we're presenting here is that all you need is just one lookup, all you need is just one search. But let's just focus on this scenario for a moment. This is a serious risk, and it would be interesting to see how possible it actually is for this to happen. So I've had this idea for a while that maybe we could use the privacy tools offered to us by EU's GDPR, the General Data Protection Regulation, to to find out what exactly is held about our user, a target user, and specifically whether that includes any passive correlations with other users that may have phoned in as contacts of our user. So I decided to try it out. In Telegram specifically, you can get all the data that's kept about you through a GDPR bot, as we see in the FAQ. Using this very simple to use bot, all we need is just 2 messages, 2 / commands to request our data, download it from the desktop app, and then finally export it in a human-friendly HTML format and browse it easily to find out there's actually no mention of our sock puppet, the one we just used to search this target account. And this is of course just an example. Telegram is a privacy-oriented app. Expectedly, it doesn't really hold any creepy data, but let's just keep this tool in our heads for other applications which might not be so innocent. Okay, with all that in mind, let's now summarize what we know about this trick, its gains and losses. First, its ease of use, as we need no crazy skills nor any specialized software or hardware to perform it. Secondly, it's hard for applications to block, and even harder to detect that this feature is being abused. Let me dive deeper here for a second. We shouldn't forget that this is based on a feature. Contact uploading is a UX functionality to help you get started with a given service and find friends. And with regards to detection, remember that address books are inherently large, and most times this is implemented with a single request to the backend. So if you've done your reverse engineering and you've successfully scripted a contact sync lookup, all you need to search multiple numbers at once is just 1 request. Also, it boasts great performance. Again, if you've reversed the API, the lookup call is instant. It takes milliseconds. Compare that to waiting for an emulator to boot, the app to be launched, and then UI buttons to be clicked. And that's before results are actually fetched and then parsed, so the difference here is massive. Finally, it offers solid result confidence, effectively low to 0 false positive hits. Compare that to the fuzzy results that, for instance, a search feature would provide. There are of course some downsides, like for starters, it's actually hard to automate this trick. As we saw, this takes some reverse engineering, which usually takes both time and skill. Even once the APIs are reversed, you also need to constantly monitor its results and keep an eye out for version updates or changes in the format. This, however, is also true for other techniques like scraping web results of an app's web client. Also, you need to typically have an active session to even perform these requests, so factor in additional reverse engineering effort for the login process and some token juggling after that. And finally, should we decide to use sock puppets and be reasonably paranoid about our OPSEC, we'll have to accommodate for the overhead of managing all these accounts and keeping them active. Before we go, here's a list of good OSINT references, good sources for OSINT stuff. First, we have OSINT Curious, the prolific Dutch OSINT guy in Twitter, and of course the awesome OSINT list on GitHub. But most importantly, inceltechniques.com are a great source of diagrams. However, unfortunately, the juice is now hidden. All these cool diagrams are not even available on the Wayback Machine, so it might take some digging to actually find these nice paths. And that's all for today, actually. I'd like to thank you again. Thanks to Koudas and Xenos for their overall help with the slides and spot-on QA advice. I'd like to thank my childhood friend Nick for that foreign SIM card that featured briefly. And last but not least, Delta, my partner in crime in the Army's Red Team, helping me out in this race to find SIM cards for the sock puppets. That's all, folks. Hope you enjoyed it, and if you haven't fallen asleep yet, there's a neat little awesome challenge coming up, so stay tuned for a chance to win a wee prize. Right, so the challenge is pretty simple. Here it goes. Assuming we have this phone number as a target, use a trick we discussed to find the 3 whales. The first to send us the solution on Discord will win BSides Athens memorabilia, a CDF certificate, and maybe a t-shirt. We'll reach out to have them shipped to you. I repeat, given this phone number, +30 694 94 22 024, The goal is to find the 3 whales, DM us on Discord, and win B-Side swag. We're going to leave this slide on throughout the lunch break. For any hints or questions, don't hesitate to hit me on Discord. Happy hunting! Right, so the challenge is pretty simple. Here it goes. Assuming we have this phone number as a target, use a trick we discussed to find the 3 whales. The first to send us the solution on Discord will win BSides Athens memorabilia, a CDF certificate, and maybe a t-shirt. We'll reach out to have them shipped to you. I repeat, given this phone number, +30 694 94 22 024, the goal is to find the 3 whales, DM us on Discord, and win B-side swag. We're going to leave this slide on throughout the lunch break. For any hints or questions, don't hesitate to hit me on Discord. Happy hunting! Right, so the challenge is pretty simple. Here it goes. Assuming we have this phone number as a target, use a trick we discussed to find the 3 whales. The first to send us the solution on Discord will win BSides Athens memorabilia, a CDF certificate, and maybe a t-shirt. We'll reach out to have them shipped to you. I repeat, given this phone number, +30 694 94 22 024, the goal is to find the 3 whales, DM us on Discord, and win B-side swag. We're going to leave this slide on throughout the lunch break. For any hints or questions, don't hesitate to hit me on Discord. Happy hunting!
Hello again. Hope you can hear me all right. Please join Leonidas for his OSINT talent. You can reach out to Leonidas on Discord for any questions or if you want to participate in the challenge. We are planning to also break for lunch. However, we also have a workshop prepared, which is about an hour long, and we will initiate that workshop playing streaming during lunch in order for you to enjoy yourselves. I mean, have something to watch during lunchtime. I really hope you enjoy the OSINT challenge. I really hope you enjoy also the event up to this point in time. We had some very interesting presentations. We also had some challenges this morning, but I think now we're good to go with sound and everything. Let me, those who are enjoying the OSINT challenge, I hope you have fun. Let me initiate the workshop during lunchtime. I hope you find it interesting. And we'll be back with you with the next talk. Stay safe and trust no one, right after the lunch break. All right. See you all in a bit. Take care.
Hello everyone, welcome to my talk. I'm glad for being here with you all. My talk is called From SE8 Overwrite with Hello everyone, welcome to my talk. I'm glad for being here with you all. My talk is called From S8 Override with Egg Hunter to Get a Shell. My name is Rodolfo Concurdi, but you can call by my nickname Rodox. A little about me. I'm a penetration tester, instructor of IT, consultant of information security throughout 30 years. I'm a certified ethical hacker by IC Council. I already gave talks at conferences as Hacking the Box, EcoPy, Qubit Conference, Arab Security Conference, Mortero.com, StackConf, Reddit Village, BSides Calgaris, etc. I'm an author at Hack9 magazine, about Stack Overflow, in Pentest magazine, about Cover Channel, from Flooded to Get a Shell, from C8 Override to Get a Shell. I leave here my LinkedIn profile by my email. For who wants take out some doubts, you can write me at my LinkedIn or my email. Our agenda. We will learn what is SEH, Storage Exception Handler, Buffer Overflow. We have a POC. In POC we will learn SEH, Overwrite, Short Jump, Egg Hunter, Bad Characters, Reverse Shell, and we have a questions. Exception Handler. Exception handler is a chunk of code from inside of an application which have the objective to handle any exception that can occur during execution of software. The exception handler looks like with. Here we have try and catch. In try, execute some code. If occurs some exception, should jump to catch. In catch, execute some specific code when exception occurs. So in flow of execution of the software, we will pass for the try, execute some code. If occurs some exception, we will jump to catch. In the catch, we will execute some specific code when exception occurs. The SE8 works in chain and they are localized in end of stack. In the classic buffer overflow vanilla, the exploit overrides the return address without worrying about writing more bytes in stack. But with the SE8 override technique, it is possible to obtain more space for the shell code in order to have an exploit more stable. So we have here in our stack, remember that the SE8 is localized in end of stack. And here we have next SE8 record SE handler. This SE8 works as a chain. An exception is an unexpected event and error that occurs in running system or program. When an exception occurs, the program's normal flow of execution is interrupted. It is important that the application can handle the exceptions or error to continue running normally. The address of the exception handlers are stored on the stack. The Windows operating system has a default handler that catches any exception that is not handled by the program. When Windows handles an exception in application, we usually see the message program has encountered a problem and needs to close. So we learn here that each program has your own exception handler, but Windows has your own exception handler. When the exception handler of the software don't work, the exception handler of the Windows work. And work when we see the message program has encountered a problem needs to close. Buffer overflow. Buffer overflow is anomaly when a program, while writing data to a buffer, overruns the buffer's boundaries and overrides adjacent memory locations. Might be WIP-based or stack-based. WIP-based. Place in the memory which allocates a large amount of data and dynamically. Stack-based. Allocate a limited or fixed size of data, such as data from local variables or functions. So we have two classes of buffer overflows, WIP-based and stack-based. Here we have an image of a buffer overflow. We have in left image variable 4 with 11 A's, right image variable 4 with 150 A's. As we can see, the stack is overwrite, stack is overwrite with a lot amount of character A's. We overwrite the register BP up SC8. As we can see here, SC8 is localized in the end of the stack. So the SC8 is a resource of Windows to handle the exception handler. And the SC8 of Windows is localized in end of the stack. Now we have a POC. The attacker machine will use the Kali Linux 2020.3 and the vulnerable software that we use is the Easy File Share Web Server 7.2. It's running in Windows XP Service Pack 3. Here we have a link for the load of vulnerable software. All became available on my LinkedIn profile the link for these slides. For after the talk, who wants to see these slides again and download the vulnerable software, we can find these slides on my LinkedIn profile. So now let's see the video POC. Let's see the video POC. Let's open the vulnerable software. Easy File Sharing Web Server is running on port 80. Let's open the vulnerable debugger, menu file, attach. Let's attach the vulnerable software. Choose the vulnerable software and click in attach. Clicking button run to run the vulnerable software in vulnerable debugger. The vulnerable software is running. Let's open the exploit code with VI. Here we have is a Python exploit code. It's an exploit code in Python, variable crash1 for a lot amount of its characters. This a lot amount of characters will send against the target with objective of cause crash vulnerable software. We will send a method get plus crash1. Below we have a target IP in port 80. This a lot amount of characters was generated by tool Pioneer Create. Let's get in folder USR Share Exploit Framework Tools Exploit, and let's execute the tool Pioneer Create with Pioneer Create -L, the link 5000, and we have here a lot amount of characters. We will copy this a lot amount of characters and paste in our exploit code For after sending this allotted amount of characters against the target with objective will cause crash in vulnerable software. Copy and paste. Let's save the exploit code. Let's send with Python xskeleton tool, send execute the Python exploit code. And in vulnerable software we have flow of execution paused, access violation, click menu view, SE8 chain, and we have a value in SE handler. Now we learn we need to find what's the offset of SE8. What's offset the SE8? For finding the offset of SE8, we use a tool parent offset. We must type parent offset -l link 5000 is a link -q, and we must type the value of SE handler 4635 6646. This is a value of SE handler, and we found offset 4065. 4065 is offset for our SE handler. Let's open the exploit code. Open the exploit code, and then we have here variable crash1 character A multiplied by 4061 plus B multiplied by 4 plus C multiplied by 4. We will overwrite the C handler with character B and character C. After plus 90. 90 means noops. Noops means no operations because it's a function that do nothing. 90 is a noop. Noops do nothing. It's a function that do nothing. So let's restart the Mooney debugger. Click button run to run the Mooney debugger. Let's execute the Python exploit code. We have here access violation again. Click menu view, SE chain, and here we have SE handler overwrite by 43, 43, 43, and the address overwrite by 42, 42, 42. We overwrite the SE handler. Click right button, follow address in stack, and as we can see, we overwrite the SE handler. We have here pointer to next SE record with B, and the SE handler with C. We overwrite the SE handler. So now we get a control of SE handler. We get a control of SE handler because we overwrite SE handler with B, C. let's open the exploit code. Now we need to find an instruction pop-up return. For this, we must type in command bar exclamation mona se8 exclamation mona se8. Click menu view log, and as we can see here, only the first 20 pointers are shown here. For more pointers, open se8 point text. So let's open the se8 file, local disk C, programs file, immunity debugger. Let's open the file se8 point text, and we have a lot amount of address. We need to find some address that make pop-up return and with secure mechanisms as false. We use address 10.01.03 FE. We use address 10.01.03 FE. This address is a pop-ECI pop-DI return. With secure mechanisms, ASLR is false, rebase is false, safe se8 as false, OS is false. We could use other address, but I'll choose this address 10.01.02 FE. This important that is pop-CI pop-DI return. With secure mechanisms, pop-CI pop-DI return. If secure mechanism ASLR is false, rebase is false, safe se8 as false, OS is false. This important that it has secure mechanism as false. And in our export code, we type here, we create a variable se8 with value fe030110. This address is an address for pop-up return 10.01.03 FE. And we type here like do architecture x86 is address fe030110 is an address for pop-up return. Now we need to find an opcode for instruction jump short jump. For this we use a tool NASM shell. We use a tool NASM shell for find an opcode for instruction pop-up for instruction short jump. We use a tool NASM shell for find opcode of instruction short jump. Now we create a variable in se8. Now let's type in NASM jump short 8. Jump short 8. We found the opcode EB06. EB06 is an opcode for jump short 8. Again, EB06 is an opcode for short jump 8. We must create a variable in se8 for short jump. We type x90 is a noop, and we will execute xb06 is a short jump 8. So we put in variable class1 character a multiplied by offset for the se8. For DAO61 is offset for se8 plus NSE8 plus SE8 plus noops, that is 90. So we'll execute pop-up return and will return for the short jump, and will execute noop noop eb06. eb06 is a short jump 8. So let's save this exploit code and execute the exploit code to see vulnerable software. We have variable crash1 with character A multiplied by offset of C8 plus NS8 plus S8 plus 90, that's a loop. Let's save the exploit code. Let's restart the Mooney debugger. Restart the Mooney debugger. Run the Mooney debugger. Run the vulnerable software Mooney debugger. Software is running. Execute the exploit code. The flow of execution stopped. Click menu view. S8 chain. Now we have a value in SE handler, right button, follow address in stack. And as we can see, we have SE8 record overwrite with short jump 06 EB9090 and the SE handler overwrite with address of pop-pop return, address 10.01.03 FE. 10.01.03 FE is our address for pop-pop return. And the pointer to next SE record, we have a short jump 06 EB9090. So now we get a control of SE record. Again, we get a control of SE record. And now we overwrite the SE record with short jump and the SE handler with pop-pop return. Let's click with the right button, go to expression, and let's find the address 10.01.03 FE. And we found the address 10.01.03 FE is a pop return, pop CI, pop DI, and the return. Click right button, breakpoint toggle, put a breakpoint in pop CI. We put a breakpoint in pop CI. Let's pass flow of execution with Shift F7, click button run, and then we stopped in pop CI. We stopped the flow of execution in breakpoint pop CI. So let's click F7 for pass pop CI, F7 to pass pop DI, and here we are in return. We are in return. Press F7 in return. F7 in return, and we follow out in loop. Here we have loop jump short. EB06. As we can see, EB06 means jump short. Let's pass the loops with F7, and the F7 jump short, and we are in loops. We are in loops. As we can see, we have a lot amount of loops, but yet this isn't enough space for put our shell code. We should now put our shell code, but I already know that this isn't enough space to put our shell code. So, when we don't have enough space to put our shell code, we use a technique called egg hunter. In our case, we don't have enough space to put our shell code here. For this, we use a technique called egg hunter. Let's learn more what means technique egg hunter. As we can see about the pop-up return, now we need to find the moon instruction of pop-up return. This instruction will, as shown image below, make a return to the pointer to the next SE8 record. The pointer to next SE8 record will overwrite with a jump to our shell code to get a reverse shell. Here in flow of execution we have access violation in current SE handler. So in current SE handler will execute pop return and will make a return for a pointer to next SE8 record. In pointer to next SE8 record we make a short jump to our shell code. Pointer to next SE8 was overwritten with a jump to shell code. So again, the flow of execution is running vulnerable software, so cause access violation. In access violation, in current SE handler will execute the pop and return for short jump. So we'll execute short jump for our shell code. In our shell code, we'll execute our shell code to get a reverse shell. But as already said, we don't have enough space to our shell code. We don't have enough space for our shell code. In this case, we need to use a technique called egg hunter. So we know that we have a little space to our shell code. For this we use a technique called egg hunter. Egg hunter is a small piece of shell code which searches for 12 bigger shell code which the attacker was not able to fit in the available buffer space. For this, make use of this little piece of shell code egg hunter to redirect the execution flow to shell code bigger. So, saying better, the egg hunter is a small piece of shell code that will redirect us for a bigger space. In this bigger space, we'll put our shell code to get a reverse shell. So, remember again, we overwrite SE handler with pop return and the short jump. We'll execute pop return and return for short jump. Short jump execute short jump short and follow out in our loops. In place of these loops, we should put our shell code to get a reverse shell. But in our case, we don't have enough space. We don't have enough space to put our shell code here. For this, we use a technique called egg hunter. Egg hunter is a technique where, in place of these loops, we will put a small piece of shell code. We will put small piece of shell code called egg hunter that will redirect us for a bigger space, where in this bigger space we can put our shell code to get a reverse shell. Let's see it in the video POC. In place of these loops, we will put our egg hunter. We must type in command bar !mona egg help egg !mona help egg, and we have here command egg. The commands of egg, we have the full value is root. We use it after root. After we learn what means this root, and we must type !mona egg for find egg hunter shell code. And we have here egg hunter shell code. Let's copy, right button, copy to clipboard whole line, copy this egg hunter shell code and paste in our shell code and paste in our exploit code. Copy this small piece of shell code of egg hunter and paste in our exploit code. Let's open our exploit code. We have here already pasted egg hunter, right button, paste selection. We have here a shell code, a small piece of shell code of egg hunter. We put in variable crash1 character A multiplied by offset of C8. Plus n SC8 plus SC8 plus 90 noobs multiplied by 5 plus egg hunter plus 90 noobs. And we have here payload 2 equals bad shards. We have here bad shards. We will send against the targets this bad shards. This value is since 01 up FF. Since 01 up FF. Let's learn more what the functions of these bad shards. Now we need to search for the bad characters. Depending on the application, type of vulnerability, and the protocols used, may be certain characters which are considered bad and should not be used in our buffer or shell code. One example of bad characters is a 00. This character is considered bad because a null byte is also used to terminate a string copy operation, which would truncate our buffer whenever a null byte appears. So, has some values that for our vulnerable software are considered bad. For this, we will send against the target this value is since 01 up FF to see if occurs some error in our target. We want to send 00 because I already know that 00 is a bad character. But already we needed to know if it exists other bad characters. For this, we will send since 01 up FF against the target for see if occur other errors. if occurs other errors, means that it exists other bad characters. We need to find the bad characters because after we will generate a shell code without bad characters. We need to generate a shell code to get a reverse shell without bad characters. Here we have other agent root plus payload 2. This means that after root will come our shell code. After root will come our payload 2 equals bad characters. Now we put bad characters, but after we put our shell code. Save the exploit code. Let's restart the Mooney debugger. Run this vulnerable software Mooney debugger. Right button, go to expression, put a breakpoint in POP. Put a breakpoint in POP-CI. Right button POP-CI, breakpoint toggle, put a breakpoint in POP-CI. Put a breakpoint in POP-CI. Now let's execute our exploit code, Python xskeleton 5. Execute our exploit code. We have access violation, pass access violation with Shift F7. Shift F7 to pass access violation. And press F9 or press F9. We follow out in POP-CI. Press breakpoint with F7, 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 F7. Pass POP-CI, POP-DI, return with F7, F7. Execute the pop return, follow out in loops, pass loops and jump short with F7. Pass our loops and jump short with F7. Here we have a small piece of shell code. This small piece of shell code is our egg hunter. Again, this small piece of shell code is our egg hunter that will redirect us for a bigger space, where in this bigger space we put our shell code to get a reverse shell. Right button scans, breakpoint toggle. Let's put a breakpoint in scans. Put a breakpoint in scans to see what is in scans. Click button run. Click button run to running the vulnerable software. The flow of execution will stop in scans. Flow of execution will stop in scans. Right button in EDX. Right button in EDX for see what is in EDX following dump. And as we can see, we have here root. We have a value here root. This indicates that after this root will come our shell code. After root will come our shell code. We'll execute jump.di. We'll execute jump.di and follow out in our bad characters. We have here 01, 02, 03, 04, 05, 06, 07, 08, 09, 0A, 0B, 0C, 0D, 0E, and etc. up FF. we will send against the target this value of bad characters since 01 up FF. Since 01 up FF. For see if occurs some error in vulnerable software. As we can see, we have all this value since 01 up FF. We have all this value since 01 up FF. This means that we don't have more error. So this means that the unique bad characters is a 00. As we can see, we have here all these characters since 01 up FF. That means that we don't have others bad characters beyond 00. So we need to generate our shell code. We need to generate our shell code just without 00. So let's restart the Mooney debugger. Let's restart the Mooney debugger. Run the vulnerable soft Mooney debugger again. Right button, go to expression. Let's find a PopCI return. Let's right button PopCI, breakpoint, toggle. Put a breakpoint in PopCI. Let's open the exploit code. Now let's erase this shell code. Let's erase this old shell code to put in this place our new shell code. For generate our new shell code, we use a tool MSF Venom. You use a tool MSF Venom for generate our new shell code. Let's use a tool MSF Venom to generate our new shell code. You must type MSF Venom -a architecture x86 -- platform Windows -p payload Windows shell reverse TCP /, host local IP /, port for listen on port 4444 -e encode shikataganai -b avoid bad character 00 -interactive tree -f file Python. Generate our shell code for file Python -b avoiding bad character 00. So here we put -b bad characters avoid bad character 00. We will generate our shell code. Avoiding bad character 00. Because this unique bad characters for our vulnerable software is a 00. So we generate our shell code avoiding bad characters 00. We have variable crash1 character A multiplied by offset plus NS8 plus S8 plus 90 nukes plus egg hunter plus nukes. And below we have variable payload2 equals buff. Buff is our shell code. We have NSE8, our jump short. B06 is our jump short. SE8, our noop, our pop return. SE8, our pop return. SE8, our pop return. We have our egg hunter. Remember that egg hunter is a small piece of shell code that will redirect us for a bigger space, where in this bigger space we will put our shell code. So let's copy our new shell code and paste in our exploit code. Copy selection. And right button, paste selection. Paste our new shell code in our exploit code. We have here payload2 equals buff, our shell code. Below we have payload equals user agent ult. After ult will come our payload2. Payload2 equals buff. Buff is our shell code. So after read ult will execute our payload2. Payload2 is equals buff. Buff is our shell code to get a reverse shell. So now let's execute our Metasploit framework to listen on port 4444, wait for connect back, execute msf console. Let's configure our Metasploit framework. Let's configure our Metasploit framework. Use multi-handler. Set our Metasploit framework. Set payload. Windows shell. Reverse TCP. We use a payload Windows shell reverse TCP. Set lhost localhost. Our IP. We configure our Metasploit framework to listen on port 4444 for our local IP using a payload Windows shell reverse TCP. Tell port of local port 4444 and execute exploit. Execute exploit. So now let's execute our exploit code with Python exclaton 6. Execute our exploit code. We have access violation. Pass access violation with Shift F7. The flow of execute is paused. We have access violation. Pass access violation with Shift F7. Shift F7 and press F9 or clicking button run. Flow of execution now is stopped in PopCI. We have stopped in breakpoint PopCI. Pass PopCI, PopDI and return with F7, F7 to execute pop return. We follow out in oops we will pass loop with F7, and jump short in B06 will pass with F7, pass jump short. We'll follow out in our egg hunter. We have a small piece of shellcode egg hunter. We put right button in scans, backpoint toggle to stop the flow of execution in scans, clicking button run to continue flow of execution, stop in scans, right button EDX, following dump. Here we have our root. This indicates that after this root, we'll execute our shell code. This means that after our root, we'll execute our shell code, because Egg Hunter is a small piece of shell code that will redirect us for a bigger space, where in this bigger space we'll execute our shell code. Pass with F7, jump DI with F7, and now we have DADC D974. This is our shell code. As we can see in our exploit code, we have here our shell code DADC D974, and we can see in our flow of execution of vulnerable software DADC D974. This is our shell code. Click button run to execute flow of execution, to pass flow of execution. Click button run. And we have in Metasploit, a reverse shell. We got a shell. So we can type net user to see the user of the victim, user hotdocs and administrator, user of the victim. You can type ipconfig for see the IP of the victim. Is it. So as we can see, we have here in these slides step by step of how you can write your own exploit code using a SE8 override with Egg Hunter technique. Remember that this Egg Hunter is a small piece of the shell code that will redirect us for a bigger space, where in this bigger space we can put our shell code to get a reverse shell. And the bad characters should be found, we must send against the target this character since 01 up FF to find what is these bad characters for this vulnerable software, because we need to avoid the bad characters when we generate our shell code. So we need to generate our shell code without bad characters, for don't occur error when we execute our reverse shell. Is it, everyone? I'll become available on my LinkedIn profile this link for these slides for who want to reproduce this POC. You can download these slides on my LinkedIn profile and execute the step-by-step of how you can write your own exploit code using SE8 override with Egg Hunter technique. Now I open for the questions. Thank you very much.
Hello. We're back. We're still on our lunch break. I have Nikos with me here. Olga will be back later on. We are still on the lunch break, and for those who want to see the workshop or all the technical talks in more detail, don't worry. Everything will be posted on our YouTube channel as individual videos as well after the conference, so you can go through in more detail, because we know that this workshop was a little bit too technical. There was a little bit too much of cell code in it, and it will be a lot easier if you have the video, so you can pause, look at it, what it says, and all that. Nikos?
Hi there from me. I hope you enjoyed all the talks. Actually, we're a little earlier than our schedule, so if you're still on your lunch break, I hope you enjoy it. We'll start at 2. I see on the OSINT challenge that there were very few that they tried to play. You still have time, so we'll see you at 2.
Excellent. So yeah, you have half an hour to enjoy your lunch, enjoy your coffee, or any other favorite beverage you might have. Most probably be in a mega pint. It's been an inside joke for the past few weeks. Yeah, and see you approximately in half an hour. Thank you.
Enjoy.
Welcome back. We hope you had a good lunch, you had a good break, you enjoyed the previous talks, and you had time to look through the technical workshop that we had earlier on. Nikos?
Yeah, I hope you enjoy our podcast here. Our new setup, it's I think better than last year, and we promise you that next year we'll have a physical event and we'll all enjoy our network community.
Well, you need to remember that Security BSides Athens is an open platform for you to come and present, share ideas. We cannot know everything, right? So it is best for you to bring your research, bring what you do, present it to the people in the audience, participate in an active manner, initiate discussions, get to know us, let us know you, get to know each other through this community-based event. The motto of the event is by information security professionals for information security professionals. We are not sitting behind any branding or any commercial products or any commercial companies. Yes, we accept sponsorships only for the sake of being able to provide you with the best open and community-based event. That means for those who have already participated the previous years, you know for a fact that you leave the event with a lot of useful swag. You enjoy the day, you don't pay anything to have an amazing day at the event. You get like all day coffee and lunch and all the other things that we do. There's usually an after party, so the drinks are also for free. So that's the only reason why we do the sponsorship, to be able to provide this community-based event to you. If you have talks, if you have ideas, if you have anything you can offer to Security BSides, it's giving back to the community with knowledge, information, whatever you want to share, reach out to us. Let's, in our new version of the event, after this limitation of the COVID restriction, let's make it even better. And our plan for next year, because we have been preparing for this, is to go really big. And you'll see what that means when we go live next year again in person. Nikos?
Yeah, I would like to end with the fact that this is a community-driven conference, and we are here to open discussions and disagreements on a framework that is ethical. I mean, if somebody disagree with somebody, he has to just on a framework that he will not offend somebody or a product. So just try to read the ethics that we have in our site and try to follow them. And I hope you enjoy the rest of the day, and see you.
Yeah, and we move on with the next talk. Thank you so much, and we'll be back very soon.
Hello, hi there. I'm Konstantina Kuku. I'm a cybersecurity expert, and I'm currently working in Checkpoint Software Technologies. Today in BSides Athens 2022, I want to discuss with you about something that for me is very interesting. It's been around for quite some time. I think that you already heard of. It's about zero trust model. It's a new term. Everybody's talking about it, and maybe has a project on it. So I would like to navigate on it together. So before actually start talking about zero trust model, I would like to generally start talking about a little about trust and as a human factor, and something that you would trust as a human. Personally, for me, I have zero trust in airport sushi. I don't know if you have ever tried that. It's terrible. I would never use a used mattress in my own place. I don't believe in competition scam, of course, as a security person. And also, I don't have trust in everything that has IP and it's communicating. So if traditional access, we would say it's about the principle of trust but verify. Zero trust is rooted around the principle of never trust and always verify. And on the network level, this is a nice picture of what zero trust would be. Next, I would like to state that zero trust security is not a product, of course. As you may know, it's a process. There are many best practices, there are principles that organizations should observe on the path to zero trust security. And to better understand that, I will drop an analogy with our physical world, with the real world. And it's not other than the airport. I think you visited quite some times. And in doing so, I think that we participate in many zero trust experiences, and all the security processes, airport security processes, are consisting a great example of zero trust implementation strategy. So to begin with, I will start with the basics. We are always verifying the person that requests access in the airport, the context of the request in a more generic IT perspective, the risk that this request may have, and then we are granting access. We require nowadays more than one piece of identification and evidence to authenticate the user. And in the case of the airport, we use the passport in order to say to state who we say we are. And we are boarding also, we are using the boarding pass to board the right place, going to the correct destination. In many places, actually, now they are starting using also some kind of biometrics for a second factor of authentication. And generally, authentication could be any combination of course, as you know, something you know, like a password, something you have, like a verification SMS, and something that you are, like a biometric usage. And another principle, I think it's very important, is that, as we said, you would never automatically trust anything. And in our example, this means that we are passing the gate, we have shown, showcased our boarding pass, but still you're not quite there. You still have to show your luggage. And this is because even when there is nothing wrong with the passenger, with you, of course, we have identified you, but there is a strict protocol in the airport that, yes, we have to check what you may carry in this luggage that you don't even know that. People are doing mistakes. They sometimes carry dangerous things on the hand luggage without knowing that. And the same is, we would say, with employees in our organization. There is someone that is really trusted. He has passed the door in the morning, scanned his card, came in the office, but he's also carrying his laptop. We know who he says he is. He's also his John. But on the other hand, we don't know what this device may bring into the organization. It could be the mobile, the laptop, whatever, and easily it could be carrying malware on it with the danger of infecting the whole network. So principle number 3 for the zero trust is that you have to monitor and audit everything. You can protect what you can see, that it is known. So you have to monitor every activity, something that usually is checked by security officers to quickly understand and react on something that seems suspicious. And this should be, of course, real time. And visibility is especially important for users who have administrative rights due to the sheer scope of their access permission and the sensitivity of the data that they can reach. So we need to say also that by doing so and by building a security architecture around these principles, what it should definitely succeed in is that it should have 0 false positives, low false positives, 0 false negatives, and it should be seamless for the user. I mean, everything we described so far in the airport example, it was generally speaking quite intuitive for the user. It required almost little experience and awareness of the process. And it is very important, we always say that for cybersecurity to be consumed, it also has to be well understood and easy for the user. And on the other hand, of course, it should be simple, but it should be preventive, meaning that We should also always take the right decision when there is a suspicious incident, and it should be blocked. And it should be efficient, meaning both for the users, as we said, but also for the administrators of the infrastructure. And it should be complete. It should implement all the principles of zero trust model. It should increase operational security efficiency overall. And of course, it should be protective for your organization against cyber attacks with real-time threat prevention. So we're talking about zero trust people. Zero trust people is zero trust passengers in our example, zero trust devices, languages, zero trust workloads. In this case, could be AI and intelligence, zero trust networks, and zero trust data. We're going to go into that a little fast. So what we have to do in each of these pillars of zero trust architecture. When we're talking about zero trust network, of course, we have to identify data and assets that are valuable for the organization. We should classify the level of the sensitivity for each asset. We should map all data flows that are happening in our organization, east, west, north, south, everything, northbound. And we should also group assets with similar functionalities and sensitivity levels into the same microsegment. For example, all the resources that the R&D is using, the source code and the ticket management system, it would be nice to be in the same microsegment. And another thing, it could be nice to deploy a segmentation gateway, whether it's physical or virtual, in the network. And last but not least, we should also define a least privileged access policy to each of these assets. For example, the R&D group should access only their own team's source code and not the next the colleagues that, although he's also an engineer, he belongs to another group. So everyone should access the things that he's enlisted to. So zero trust people, we are talking about people a lot and their involvement in cybersecurity. And the thing is that we have, of course, to authenticate user identities on the network level, and not, if possible, at the application, meaning that you don't allow authenticating users closer to a security gateway on the network level. Will block hackers from getting too close to the system and dramatically minimize this way the attack surface. Of course, you should do and use SSO, which simplifies the process of authentication. Reassuring our identities with multi-factor authentication is a must. And also, you should set context-aware policies, meaning narrowing down the definition of authorized connections by adding multiple conditions regarding the context of the connection. For example, you may think that this resource should be accessed by this partner that connects from Greece only 9 to 5, and this is something that should be implemented on the network firewall. And of course, we are talking also a lot about that, detecting anomalies, compare connections with the baseline that we have, and for example, identify unsuccessful logins, unusual times and location, and more, and be able to act on this event. Zero trust devices also. When we're talking about that, is to take a practical approach to minimize the attack surface that comes from the devices. For all workstations and mobile devices, of course, no matter if they are corporate or also personal, it should carry some security controls by the corporation in case it touches corporate data. So it should have some kind of protection against the zero-day malware, ransomware. We should have protection against zero phishing and all the stuff that we are currently doing at the endpoint. And of course, we should block corporate access to the devices that are infected. So posture management and conditional access should be also a solution of zero trust devices. And of course, the first thing, we are talking about segmentation. It's always a good idea. IT, IoT, OT, whatever you have in the network, it should be segmented on the useful, on its practical side. When we are talking now about zero trust data, we want to enforce encryption on the portable media. We want to provide secure access for remote users. We want to apply DLP also, DLP rules for our users and the classification of the data that is being used. And a nice tip here is that in order to raise the employees' awareness of the data use policies that you have, we know that DLP can be very hard to implement in your organization. You can release some self-remediation DLP policies that will allow to notify the user for improper data handling that he's making in real time, and have the option for him to send, discard, or review the issue. It's a kind of training technique that is accommodated in many solutions, in many DLP solutions. And actually now the other part is about zero trust workloads. And now we are talking about, as you understand, application workloads, things that are sitting on the private cloud or the public cloud. And here, of course, you have to identify all the cloud assets that need to be protected. At every point that our organization has data needs to be protected with similar protection and with unified policies. And we should identify everything that is related to the cloud. We could have a database server that connects to the cloud through internet. Of course, it should be also listed and have the correct way of communication. And define internal segmentation based on list privilege. We said that before. I think it's very, very important. Visibility and analytics, and I think that I'm slowly coming to an end of this wrap up of the zero trust model. Visibility and analytics is a key, I think, in everywhere. In order to simplify all these solutions, they are technical solutions, but also we are talking here, zero trust is also a framework. So we are talking about processes, but overall, we should have in place some ways to easily check our effective measures, to check what we have implemented, to have our logs and to revisit them in order to daily and in real time, of course, to understand the anomalies. And whenever you can, of course, you can leverage the threat intelligence services in order to have indicators, real-time threat indicators that are aggregated in order to share, to have useful information that is shared among all your enforcement points. And finally, I think that wrapping it up, it's zero trust is something that needs to be discussed and needs to take the right approach, see what the control, but I think it's more about the mindset, about what we can do, and all this never trust, always verify. I think it's very important. So it's zero trust is here to keep us safe. The implementation should be practical and easy to consume. We want to be effective, and better security always matters. And I think in the future will be an even bigger concern. So it's nice that we act practically. So stay safe, trust no one. I know that this is sounding a little strange, but this is it when we're talking about cyber attacks. I have listed here some useful links. Maybe you can also revisit. And that was it. Thank you very much. Enjoy the conference. Bye.
Hello everyone, I'm really excited to be here with you guys, reporting here from 12sec at this year's BSides event. My name is Ignatios, and today we want to talk to you about a challenge we had in one of our SDLC engagements with one of our partners, for having to shift the penetration testing, which in our case was actually in an API-driven application, the API security testing earlier in the life cycle of a process, of the SDLC process. So we want to share with you our experience, what ideas we had, how we came up with a solution, and of course, since this is also ongoing for us and we're going to see how it's going to progress over the next couple months, we also want to hear your feedback and get the conversation going on what you do in your engagements in terms of processes, tools, and the like. So for anyone who doesn't know us, 12sec, we are a cybersecurity consultancy firm. We offer all kinds of consultancy services. You name it, we do it, from red teaming engagements, penetration tests, SDLC engagements, and the like. So moving on to the next slide, let me give you just a little bit of information so that you know who is talking to you. I'm a software engineer for 4 years, and I have been application security engineer for 7 months since I made this transition and joined 12sec. Since then, I have been involved in mainly SDLC engagement as well as some infrastructure configuration audits. And I am also a CSSLP credential holder and a cloud practitioner from Amazon, now starting my journey to the cloud security certification path. So let me give you like a little information about what we're going to see in the next slide so that you can have a clear map of what we're going to present to you. So I will talk a little bit about the engagement and the activities that we're running, the requirements that we're having, some architectural characteristics of the application at hand, which will be a source of input for us for the solution that we have to make and the factors that we have to consider in order to choose the right processes and tools to do the job effectively. So this is an SDLC engagement. We run all quite bunch of activities here. We run risk assessment. Well, risk assessment not exactly in the phase of an agile sprint, like in a week sprint where we run it every time, but more like an inception-like report. But it always comes handy because you need to go back to this report to refer the general risk overview or policies or classifications in terms of confidentiality, integrity, and availability of the data that your system processes. And it also relates to the prioritization of the cases that you want to implement in a test suite so that you can have the most measurable outcome in the most the return of investment on the test cases you do in your security automation, as well as other activities, of course. We do requirements analysis. This is a sprint-based activity when we we define security requirements, of course, in addition to the requirements we have, and if they are not needed, specific security requirements related to the business cases at hand. And of course, these requirements will also relate to how we will define our test cases, of course, with other requirements we're going to show in the next slide, which will be our general application security requirements framework. Then we have here the architecture review. We exclusively do SVS on this. We run L3 for critical applications, and we do also threat modeling using an automated tool called Tirius Risk. Not automated in a sense that you don't have to do anything, but automated in a way that it's not like in a Word document where you have like hundreds of pages where you have to do your threat model, and it can get really messy and huge quite fast. But it can offer like a good view of your risk status and generate controls based on a specification that you provide. And this, of course, is the main source for us in regards to the business logic as an attack surface, which we want to cover in our security automation suite. Then we have source code review. We do this manually sometimes, not so often. We have guidelines specific to the platform where we are testing. We're also using static analysis plus a specific set of rules which are signature based, of course, to identify vulnerabilities in the code as soon as the developer writes the code. And we also have composition analysis for our third-party libraries. Then moving on, after the normal tests are run, we also run a dynamic application security testing tool. We run ZAP to identify common vulnerabilities or web application misconfigurations. We do this. It has come out handy from time to time, though now it's where the things are more mature and a lot of security controls have been implemented. There is not so much to go on from this. But this also is the main reason where we want to have is that this does not cover the actual business logic we want to test on this application, which has a bunch of functionality areas with many different business flows consisting of multiple steps, integration with external system, and this really is the attack surface we want to cover. Moving on, we have the penetration testing, then infrastructure audits. Infrastructure audits are conducted against the cloud-based environments. Now the penetration testing is the only actual in the highest level of security assurance as a verification activity in terms of this attack surface we're trying to have covered earlier in the life cycle. It offers the best we can, it offers the best assurance as possible, but it's not conducted on a sprint basis, and that's what we want to tackle in our initiative to move this a little bit earlier in the life cycle so that we can leverage from this assurance the penetration testing only can provide. We also have the requirements. We have ASVS, we have specific chapters that are applicable to the problem we have at hand, and will actually be a mapping for the solution we chose, and the specific chapters in ASVS like secure file uploads, API architecture, access control, and others as well. We also have some regarding some. We have the goal of this initiative we took with security automation to reach maturity level 3, which actually mandates to have integrated security testing as part of your pipeline. So, moving on to the architecture, we are basically running a single page. This is about a single page application running an Angular frontend. We have a couple REST APIs implemented in Java in the backend. For our authentication architecture, we use OpenIDs, the standard flows of the OpenID of the auth specification. For our authorization architecture, we mainly, like in the high level, we have a role-based access control consisting of multiple roles and hundreds of permissions for different functionality areas. And we also have function level access control, implementing authorization checks at the function level, trying to mitigate violations that could occur if we were only taking the role into account in such cases. And our accountability architecture, which is often overlooked, we want to highlight it, and because it's important from a compliance point of view, having to log the right stuff with the right way, taking care of the privacy of what you log, and of course the sensitivity of the data you log, and keeping an audit trail and keeping people accountable for what they do in case of a forensic investigation or whatnot, and be able to cover this and provide the information that will be needed in those circumstances. So, going to the problem at hand, the first problem we had is regarding our sourcing. And when I say sourcing, I basically mean how we're going to source our test cases. I mean what will be our source input for defining those cases. So we had a couple options here. The first one was to crawl the application. I mean, I have like a tool like burp, intercept the traffic and give all this valuable information such tools can provide. And from there, based on the information that we get in the endpoint identification, begin writing cases. This would be really fast, although we didn't like the fact that we have to consider the application behavior and the responses we got as the single source of truth for defining what was meant to be the correct thing to do, which we didn't like because something might have been implemented wrong. Now the other option was to do a source code review. We could do like a regular expression on the source code because we have access to the source code, identify all endpoints, and from there reading with the code, which would take significant resources, of course, but it would be a more wide-based approach to do this and have like a really good coverage, but it would also miss the documentation and misses the opportunity to leverage all previous activities done in the life cycle so that we can have them all, we can have like cases directly derived and collaboratively decided between security, architecture, as well as business analysts from the client side. And of course, the other option, which seemed also more natural to do, is the documentation, which we already had in a way. I mean, not like always updated, not in a perfect state all the time, but the best possible place to really identify the business logic flows, which we are most interested in, because this is the attack surface that is most hit by the bad guys. We want to keep out is the business logic of our applications, and we wanted to really have this attack surface covered and documentation seemed like the best option. So the solution to that was to create an access control matrix. Now, an access control matrix we didn't have at the time, but we liked the value it offered us in terms of visibility, because we already have some of this information scattered all around in the user stories and use cases. We had like some authorization permissions in where they were applicable in some user stories, but now what we have is a single Confluence page. Well, it could be in other formats as well, but the most important thing is that we have a single source of truth regarding the authorization schema of the application as a whole that could be also be used as a basis to also engage developers and architecture team, ideally to review, to keep this on track, to have this on their sprints or their definition of done or their workflow, and have these actions implemented there, even from the analysis or from or leverage those actions in the test cases, as I will show you in a minute on how we do those cross-reference. So this cross-reference is actually having to being able to track what the test cases are and where they come from, so that when you go maintain this test suite of security APIs, you know that this test relates to this functionality and you can check what exactly lies beneath, right? And this, of course, has to do with business logic, which is our primary focus here, and we want to identify those flows, and this will help us do it more effectively. Now, the second problem we had is how we want to structure our tests. Of course, one very a natural way to go is to go using the endpoint paths. Now, the endpoint paths, I mean, it is quite what it sounds like having the URL in a sub-resource way for URLs included in an endpoint, and then structuring your tests based on that, which would achieve a good amount of coverage, I guess, but it lacked the security side focused of things, because we wanted our structure to be specified so that it can help the tester or the developer who is writing a test to think about those key areas that we want to have security-wise covered. So the other option was to go with the specification, and of course the solution was to use the OS project API security, which has insufficient categorization, it's community-based, and it's open source. And I mean, it pretty much does what we like. And of course, the thing is that there is no other non-structured alternative as well. But regardless, it is what it is, and it does what we want, and really gives you like the basic backbone of mindset to write test cases upon for modern API-driven applications, right? So the next problem, what tool are we going to use? Here we really care about CI integration capabilities, we care about what APIs we support, and of course we care about the learning curve the developers would have to familiarize in an ideal scenario where they also engage in this actively and make this part of their sprints. And we also want to make this more easy to them to choose a tool that will be familiar as well to them. Solution is Postman. Postman accomplishes exactly that because developers already use it in ad hoc purpose, not like security focused testing, but they choose to test their APIs in some way or another. We have dedicated documentation sections which we really like and we highly leverage to both refer to our access control metrics so that we can have this tracking that I talked about before, but also to include our test data which the specific test case refers to. We also have flow support, and this is about what we were talking before actually on the business logic identifications and transaction-based flows, which we highly want to cover, and we cover only on the manual penetration tests on big milestones, but now we want them covered as soon as possible. Now, Postman has seamless integration with Jenkins, not like in form of plugin. Jenkins is a continuous integration server we use, and we can use it as a build step, have ready to use Docker image step. Now, the other problem we had is how we're going to track our data. So for a test suite to run, you need a couple data. You have test data scripts being responsible to create all this data you need for a specific environment. We don't have the scripts at this point. We're in the process of creating them, but we had a couple options to do a Confluence page, which would be a nice choice because Confluence has this reviewing and history. We also could go like a more sophisticated to tackle issues that would come up in the future if this got big and wouldn't be so easy to scale in a Confluence page. But a test data management solution is not what we could suffice with right now. So we could go also with an all-time classic Excel sheet, which would be really fast to do. And this is what we chose in terms of being straightforward, in terms of being fast. And of course, we know that it won't scale, but we have this tract, and we can start our way low and see how all this whole thing progresses. And what I want to really note about here is that even though you're using an Excel sheet, it's always important to keep the documentation. Documentation, guys, like really important, makes things so much more maintainable. Like even a simple sheet that I'm going to show you like in a little bit, you can have like a documentation tab where you document your columns, specify some common convention to use, and there you got it. You have something that can be more easy to write and maintain and assure some common format on this so you don't have discrepancies and inconsistencies. So thank you all for watching this here from 12sec. We wish you all the best, and moving on, we hope you found something useful out of this to do in your engagements, or give us some feedback regarding what you would like, what you think should be best in terms of approach, in terms of processes or tools. So moving on to the video, please. So hello again everyone, moving on to the video. Unfortunately we had some problems setting up the environment that we have configured Jenkins to run our test suite on. Alternatively, we're going to run the test suite on one of our dedicated environments for verification purposes that we hold in our premises. But still, I'm going to be able to show you a lot of the stuff that we discussed on during the conversation regarding Postman and its features and how we leverage all the cross-referencing and the like. So, as you can see here in the collection, we have the collection structure as per the specification of OWASP REST API security, which mainly is security focused and highlights the key areas that we would like to test as part of our security API testing suite. Next, we have the documentation section where we outline basic stuff regarding how we write and maintain our test cases, as well as some information on the references we have on test cases themselves. As you can see specifically here, we have the associated action from which is actually the identifier of the action in the action control matrix, as I'm about to show you in a few seconds, and the identifier from the test data that are needed to run this specific test case. So as you can see, the identifier here is C68. We can see the respective action here and the URL that is going to link to the analysis for this specific action, outlining the requirements and all the business logic scenarios that we highly want to test, and that way give the tester or developer that's writing the case or maintaining it a very good idea on what this case is about. So moving on, you can see here the test data. Test data was simply, as we said, tracking in the test here, just having this test data and tracking them and having some documentation on how these columns are used and some common conventions on using in this sheet. Moving on to the Postman, I want to show you some features that might come handy for various use cases. For example, flows, which is a very good feature of Postman that can chain multiple HTTP requests, but also can do whatever else you can imagine pretty much, because it can go like from logical testing to XPath evaluations, encodings, decodings, parsing of various output that can occur, and also another very interesting that we find about is the delays. Delays can be used, like for example in our case where we have external system integration and we must wait for some time interval before we invoke an endpoint. We're going to use delays for these transaction-based complex flows. And then again we have the environment variables. Environment variables we can use to share and not use the same data all the time in the test cases as we do in our base URL environment variable here, but also as I'm about to show you in the Jenkins configuration, we're going to use the environment variable argument to the container of Newman we're going to set up to pass this variable at the runtime container where this suite is going to run. These variables are also can also be defined as secret. As you can see here, you can select the type. This way we can mask it to prevent any information disclosure. One other interesting feature of Postman is the attachments, because you're gonna have like some multi-part requests, of course, which is going to include upload and attachments to test the upload endpoints. Postman through the settings gives us the capability to define a directory. Now don't mind my own, this is an absolute directory to my machine, but Postman gives you the possibility to define a directory where it can be referenced by multiple machines so that you don't have file resolution errors. I will also show you how the outcome from the actual test suite running in Postman is going to look like, and I also want to highlight like specific methods that you can use so that you can have like more clarity in what your test actually tries to verify. Of course, going also to be covered in more depth in the reference to the access control matrix itself. Now moving on to to Jenkins, as you can see here, we have some basic configuration ready, or we pull the Newman container ready to use Docker image. We specify the directory we want to have inside the container, specify the collection to fetch from a GitHub repo we have in the previous step. Also, this is environment variable we're passing, as I told to you before, so that we can affect the runtime behavior of the collection, and also some report outputs that may come handy in various use cases on how you want to process the output from the test cases. So this is all it. Thank you very much for watching this, and please share any feedback you might have or any questions. Thank you again.
Hello again. Welcome back. I hope you enjoyed the talks up to this point. We're very pleased that we had some engaging discussions over Discord. Please do engage with us on Twitter as well, and we also have this Instagram page. We would post some of your pictures that you sent later on. Yes, we were having a heated discussion back here regarding international renowned hackers, Greek and foreign, obviously. And the idea is that give us your recommendations. Let us know who would you like to see in Athens next year. The idea is that you post the names, we reach out to them. We're going to put it on Twitter as well to engage with more people. Whatever list of names we end up with, we're gonna create a poll, and I think the top 5, I guess, depending how big the list is, I'll make sure that I reach out to them and get them in Athens next year. I think it will be really nice interactive version of doing things. Not that we haven't brought very famous people over the years in BSides since year number 1. You can go back to our previous events and check them out. Nikos?
Yeah, well, it's a hot discussion. I hope next year we'll not have all these COVID restrictions. and will be physical, and people will like to travel. I mean, BSides Athens can be one of the best. We have the whole package. We have great weather, good food, good people here, and the community can get together and enjoy the event. I also enjoyed your pictures that you send in Discord, and you are seen as live in your screens with popcorn. So that's for me.
Yeah, and yeah, it's not only about hackers, obviously. Like, if you want to see any particular professionals, like in 2020, I think, when we were planning to have the next physical event, the keynote speaker was the group CEO of Airbus. Like, and he was planning to come over, and everything was ready, and then COVID hit, and he had to do the talk remotely. So he's also very much willing to come to Athens whenever we do a physical event. So anyone else that you believe you want to see in Athens, but they're just a phone call away for us. So let us know, and we'll get it done. Okay, moving on to our next talk. Enjoy, and we'll be back very, very soon. Take care.
Hi guys, this is Ergi, and today we're going to talk about vulnerability. I'll start with a few words about myself. I'm the Business Development Director and Chief Information Security Officer for a major Greek integrator and managed service provider, and I'm the membership chair of the Hellenic chapter of IC Square. I'm also a published poet and a retired hand-to-hand combat instructor. Now, the agenda, which I'll try to follow, is going to include the significance of vulnerability management, a few words about human firewall, which is excessively important, and a small episode of work-life balance story, or better, life-work balance, as it ought to be. Now, starting from the vulnerability, in a more generic way, vulnerability is the quality or state of being exposed to the possibility of being attacked or harmed, either physically or emotionally. You should stick to the emotional part. When we're talking about a system, it's any flaw or weakness in the system's core, procedure, control, design, or implementation that can be exploited. So the security posture, the security policy of its system can be violated. When we're talking about systems, of course, I'm referring to any server, workstation, network device, IP camera, IP telephony thing, or anything that has an IP and can be reached by a potential intruder. Now, I'll start off something pretty common. I'm talking to a BSides crowd in any case, the IKSC, the intrusion kill chain. You know, I interact with a lot of customers, and when I'm talking to D or C level executives, I give them a glimpse of it, stating that you see that vulnerability, the word vulnerability, and it's like vulnerable here, it's referred in the step 4, the exploitation part. But if we do something about it, the absolute truth is that we're going to impact the very step 1, the reconnaissance. So you see here, it says research, identify and select of targets. What I'm stressing is that having a controlled vulnerability posturing, keeping your vulnerabilities, in simple words, as low as possible in significance and in numbers, will prevent like an attacker, which is a random or a semi-random attack, to harm you. So the aggressor will find a weaker potential victim. It's the same as bullying. But even if something is really targeted, again, we're gonna make the life and the effort of the aggressor very, very difficult by having a nice and neat public footprint. So, moving from the IKSC, we see that this effort to have everything in control is actually a life cycle. I mean, that's no news that everything in ICT and cybersecurity is not a straight line from A to Z. It's not a one-time thing, but it's a recurring part. So we really need, I mean, in simple words, here we're seeing 6 nodes, but in simple words, we need to assess, report, and do something to remediate, to fix, either permanently or not, the vulnerabilities that we have. We say remediate, but I mean compensate as well. So maybe there is a 0 day that is out in the wild for a few hours. There is no patch from the vendors yet, but still maybe we can harden our IPS policy or put an extra access list in our border firewall, or maybe apologies for that, put a web application firewall as well. Anything that one can do to mitigate an issue. And again, this is a process-based action. Like we need to verify, discover, and again run the drill from start. So the main thing is that we need to do it consistently. Key here is to fix the important part consistently. When talking about consistency, of course, there is a maturity model. I mean, many of you should already know the CMM. So this is a CMM approach to the vulnerability management. I won't spend much of the time here, so we really need to be proactive. The photograph is not optimal, but the key here is proactive. So we'll start from step 3 as a baseline. We need to have something really defined, and then it needs to get as optimized as possible. Now, step 4, the optimization is again another life cycle approach. So there are levels of optimization and so on. As you see, as the aggressor, they become more and more agile and more dynamic. The same needs to happen to your vulnerability management strategy. And of course, code cannot be excluded. I mean, I have a few customers running software development companies, and they say, RG, I mean, we have outsourced everything to our cloud providers, to Azure or AWS or Google, or maybe we have a few of them around, like the inter-cloud approach. So the provider takes care of everything because we're utilizing and buying platform as a service. But in a vast majority, unfortunately, they're not incorporating security controls in their SDLC, so they end up identifying a few issues, even if not following the waterfall model, and they are agile. They state that they're agile. They run some tests at the end, so they end up accepting an enormous residual risk, or spending a lot of money and effort and money again to fix some things before they go live. So for me, OWASP is out there for 15 or more years. There is the ASVAS version 4 now. It's the application security verification standard. We should all target for level 2 as a baseline. And guys, if your application uses critical data like financial data or personal information or sensitive information, you should really target for level 3, even if it's not easy to fulfill the 286 controls. At the moment, I've seen out there a lot of very nice apps. I mean, people spend enormous money in UX and UI and for marketing purposes. Oh my god, I mean, to convert customers, and then they get hacked by somebody because the application is not is poorly written security wise, and that's the same. Now, this is the human firewall. It's a big commodity. It's a big buzzword out there. It's something that as a term started a couple of years ago, but it's true. It's fundamental. You can spend crazy money on next generation and next generation things, and then you have your user plugging in a USB device or click on a link, and that's it. you're pretty much fucked. Apologies for the language, but it is highly essential to train your users. And as I stress, and I don't stress enough sometimes, and your security team, I mean, okay, they're IT guys or InfoSec guys, and they know how to. Hopefully, they know how to check if an email is a fraud or not, or they don't use their personal USB stick at the office. But you need to have an incident response plan. I mean, even if you're not abiding a framework like ISO 27001, NIST, BIMCO, or IMO for shipping, you need to have some processes around, and you need to check them along with the other stakeholders a few times per year. I mean, when something happens, because inevitably something will happen, that's good that it won't be something serious. They need to reach out to the management, to marketing, to legal, and engage all the stakeholders. So everyone involved needs to be trained. Now, this is a photograph. We're gonna be staying in the human asset part. This is a photograph that I chose the last minute to include. It's nice because it starts from the comfort zone as something that we were in the past, and that's true. And it refers to the stretch zone. You know, I usually wake up quite early for multiple reasons, and I used to listen to all this motivational speaking and how to become the best entrepreneur, the best executive, and they often refer to the stretch zone. You need to fight and fight and fight and become better, and that's true. But there are limits to it, and nobody really refers to the panic zone, which is what comes if you haven't set your boundaries. So the ultimate truth is that human assets, and I'm referring to actual people, they can also be vulnerable in aspect to breaches, which means that no matter how they look outside, I mean, they can be very functional, they can laugh, they can work with you, they can eat okay, they can go out with for a beer with you, or and you think that they have a perfect life. They can still be vulnerable, and they can feel bad. And when I'm saying they feel bad, I'm talking about anxiety. This is Mr. or Miss Anxiety. They can be stressed. They can feel like shite, and that's a very important thing, because then your next generation firewall looks something like this. This is your EDR. And this is your web application firewall, all your DLP. So, but these are just tools, just instruments. They are compensative measures, but they don't really remediate the problem. So there are things that we should do. This is a picture of myself a few years ago. Unfortunately, this is something that I'm sure that it looks familiar to a lot of you when you look yourself in the mirror every morning. And it doesn't matter. You don't have to be an executive to feel like that or to be like that. But hey, there are ways to turn this around. So we're gonna talk about your remediation plan here. We need to learn to say no, and believe me, it doesn't have to do with poor management, time management skills. There are people, yeah. There are things and people that we need to say no to. So that's important. Again, establish boundaries. It might, it might look the same, but it's not. There are some lines that we should never cross regarding our well-being, or the life-work balance, as I said in the start. So yeah, maybe don't work 16 hours every day for many years just to buy a brand new car or something. It doesn't worth it. we should ask for help, and I mean professional help. Yeah, you can talk to your parents or to your better half or to a friend of yours, and that's fine. But professionals are out there. It's the same reason people hire us to do a professional penetration test or a vulnerability assessment or something, and they don't reach out to for a freebie out there. And very important, try to build a positive relationship with your boss as long as it can happen. If not, maybe you can change your boss. You know, now is a good time to refer to the footer of the presentation. It says the first time is a mistake, second time, and obviously every other time on top of it is a choice. So reaching to the end, thank you everyone. Stay safe, security wise, and mentally sane. And I'll talk to you when I see you around. Thanks, Emil.
Hello. Hope you're joining up to now. We are supposed to go into a coffee break at the moment. So there we will make a small change to the schedule. We will move to the next talk instead of going to the coffee break now. And we will go into the coffee break after this talk. The reason being is because we are arranging for a last minute surprise, which we want to do during the coffee break. So we need a few more minutes to see if we can make it. So please enjoy the next talk. And after that, when we go for a coffee break, we hope we will have something ready for you to also enjoy. It's all about hacking. So stay tuned.
Hi everyone, pleasure to connect with all of you today. My name is Sapendra Dev, I'm founder and CEO of SecurBlink. So in today's session, we are going to talk about the future of application security and what are the key challenges which are faced by the organizations. So let's start with the agenda. So we will be covering up the topics which are related to what is application security, why the application security is important, the type of application security, the common application security flaws, and what are the application security tools which has been used by an organization, then what are the key challenges which are still in organizations are facing in terms of application security, and the best approach the application for the application security, the current and the future one. So let's first start with the what is application security. So application security is a process of developing, adding and testing the security features within the application to minimize the security vulnerabilities. So it is just like that we are adding the multiple layers to an application so that we can make it proof, like we can make it like secure from all the external attacks, and whenever like an hacker will going to try to penetrate those applications, they need to pass through the multiple security layers. So this is how like we are improving the overall security of an application, and this process is known as an application security. So where we are like identifying the early stage of vulnerabilities, and then we are reducing and we are eliminating those vulnerabilities with the approaches and with the different kind of like the products and the tools that we're going to use. So why the application security is important? So let's start with some couple of sets that we have captured mainly from the Flexera, Micro Focus, and the White Hat Security, which says that the 60.5% of the applications vulnerabilities are remotely exploitable. 42% organizations experience an external attack due to an application security flaws. 79% of the organizations push the vulnerable code to the production either regularly or occasionally. So this is like mainly taken care by the organizations which are like early stage or which are like in the medium stage, because those in those organizations they don't have any security teams, and maximum of the development deployment work is taken care by only the developers. And if they by mistake push any kind of vulnerabilities which are associated in their code, and if they push it in the production environment, automatically it is making them more vulnerable of getting a cyber attack. Then 42% of the vulnerabilities in the applications are SQL injection errors, because even in today's time, a lot of enterprises applications and small medium business applications are using the previous tags, so they are more prone of getting the SQL injection attacks. Then 83% of the applications are still found to remain vulnerable after the initial scan. Simple like if we start with the initial kind of a scan, because scanning is just not the one process. It's just like a very basic process which the company and organization just follow. But after that also like they are again will be remain vulnerable of getting a cyber attack. And 50% of the apps on an average like they found vulnerable because they didn't adopted DevSecOps approaches. So this is a trend like a graph that we have created from 2009 to 2020, and which says that shows the rapid increase in the vulnerability, the open source vulnerability. And if you can see like from 2019 to 2020, there is a drastic change that we have got, because in today's time like organizations are including a lot of third-party libraries in order to make their applications more robust and to provide the best user experience to their customers. And in order to do that, they are basically following up with a lot of third-party libraries, and which is automatically making them more and more vulnerable of getting a cyber attack. So the top security flaws that we have captured, which has been covered by, reported by the Veracode and CWE Mitri. So Mitri is a framework which is like followed by all the enterprises. And it says that in the common flaws, if we talk about, these are the popular common flaws which have been found in the application. It starts with the information leakage, which is coming up like at 64%, then the cryptographic abnormalities, which is like 62%, then CRLF injections, the code qualities, insufficient input validation, cross-site scripting attack, directory transversal, then credential management. And if we go for the top 10, like the top 10 CVE, which is being given by the MITRE for this year, for 2021, which starts with the out-of-bound write, which has the threat score of like 65.93, then cross-site scripting, which is like 46.84, then out-of-bound read, which is 24.9, then improper input validation, that is 20.47, then OS command injection, that is 19.55, SQL injection 19.54, then use after free, path transversal, then the cross-site scripting, froggery, and unrestricted upload of a file and a dangerous type. So all of these detail, like if you wanted to know what these terms mean, so that is like widely available over the CVE Mitri websites, and you can just go there and you can just search about these terms to get a more detail about it, because here we can't like cover all the topics at once. So I'm just giving you an outline of like the top application security flaws which has been followed by, which has been like experienced by the in today's organizations. Then moving to the next, we are talking about the type of application security. So the application security is mainly divided up into the 5 types, which starts with the critical infrastructure and security, where we are talking about the applications which has been used in the critical infrastructure, mainly with the power grid, with the electricity segments, and with the nuclear reactors. So all of these critical applications, they are again like the cybersecurity is required in that because they are handling those critical infrastructure. Then moving to the next, then we have the mobile and web application securities, which is related to all the mobile applications and web applications that has been used. Then the network securities, again the network securities plays a very important role because this is the first contact, the first entry point for a hacker. And if he gets anyhow the credentials of the private network which has been used by an enterprises or an organization, they can definitely enter into their database. Then the cloud securities are there, which has been like in today's time, maximum of the applications are getting deployed over the cloud, so they need to follow the various kind of approaches to adopt those securities. Then the IoT security is there for all the IoT devices. So what are the application security challenges which the companies are facing in today's time? It starts with the inherited vulnerabilities, like some of the code that they are using and reusing it. So the vulnerabilities are getting inherited from the previous codes, okay, or from some like the third-party libraries, which again making them more and more vulnerable of getting a cyber attack. And the second, we have the third-party and open source vulnerabilities and dashboards and software supply chain attacks, which have been recently experienced by the lot of big organizations, mainly based out of US. Like if we talk about the Colonial Pipeline, if we talk about the other hacks which has been taking place in the recent months, so they are all like affected by the software supply chain only, which is one of the highest challenge for an organization in today's time. Then the vulnerability detections are there because still the organization doesn't have the robust solution in order to detect the vulnerability in the runtime environment. And the API security is that again plays a very important role because if an organization have some endpoints which are publicly available and if they don't like deploying any sort of a security in that endpoints, then automatically like the hacker can easily access those customer data sets. So what are the application security tools? So these are the popular tools which has been used by an organization. It starts with the static application security testing, and dynamic application security testing, then interactive application security testing. These 3 approaches are mainly followed by all the pen testers, the cybersecurity and others, and they start with the application testing while following these 3 approaches. So then we have like the software composition analysis. This is something a bit new because here we are analyzing all the components of that software, and we are then drifting up and finding out the vulnerabilities which are associated to a very code level of an application. Then the new approach, like a lot of tools are being offered by an organizations which are basically providing up the application security testing as a service. So the application security trends. So basically the raise that we have seen post-COVID, like in the new normal, the organizations are now moving towards the cloud. Like they are not at all going forward with the on-premises servers, which has been followed by the previous approaches. In the post-pandemic time, now the people they have adopted a hybrid model of working from home. So definitely they need to move their applications to the cloud. So the rapid movement of an application and the rapid cloud adoption of an organization is automatically it's at the scale which we have seen in the past couple of months. Then the runtime application self-protection, this is also again being followed by in the terms of trends in the application security. Then we have the runtime application self-protection, RASP. This is one of the most popular approach which has been followed by the recent CISOs, CIOs, and the security analysts. Then the backend as a services, where we are like companies are following a very robust approach in today's time, where they are created a backend as a service. So they are deploying the microservices there, and they are utilizing those services in the secured environment, which is much more secure practice comparatively to the traditional approach of deploying a monolithic architecture. Then we have the monitoring tools which are available mainly for the public and private clouds. Every cloud companies have those monitoring tools available. If it goes from AWS, from GCP, from Microsoft Azure, everyone have the monitoring tools available. And even like a lot of other third-party companies are also offering, which we can directly connect with those cloud providers, and we can monitor all the traffic, the inbound and outbound traffic of an application. Then the web application firewalls, they are basically the previous approach, which is mainly followed by an organization. They just deploy the firewalls, and then the function as a services, again, it's a serverless model which has been followed by an organization and application workload protection. This is pretty much new, because in today's time, even what the hackers are doing, they are basically using the memory. They are creating, deploying the memory based kind of attacks, which are very difficult to figure out or to detect by the traditional application security scanners. And this thing we can easily detect if an organization is using any sort of tool which is based out of workload protection. So then, in the last, we will be talking about all the approaches, the current approaches and the future approaches, which is being taken by an organizations for the application security. So the current approach, if we talk about, is they are adopting the advanced application security frameworks. They are creating the code, the secure code. They are monitoring the complete code, and they are checking whether it is not coming up from any sort of from the third-party popular forums. Then implementing the security as a design. This is one of the most recommended approach, which even I do recommend from my end, and which the organization need to follow whenever they are designing or developing any kind of a product. They need to implement the security as a design, so that at every stage it should get into those security layers, and which automatically will make the hacker work pretty much harder. Then integrating a security into the development, the software development stages, where we are deploying, testing the CI/CD pipeline that we are talking about. So we're integrating the security in that part also. Then using the latest web technology. So it is basically organizations need to adopt all the latest technologies which for developing up their application, whether it is mobile, IoT, or web applications. Try avoiding the previous techniques or the previous technologies which are not getting any frequent updates, because those frameworks and approaches are getting more vulnerable of getting a cyber attack. Then regularly they need to update their softwares with the recent patches and the recent updates which are being rolled out by an organization, because they are very important and they contain a very important security critical threat, critical updates. Then the future approaches, so arrange and prioritize the application. This is going to come up in the future approach, where we are prioritizing that which application and is more important in an organization and which is handling the more critical data. Then data should be encrypted. We need to verify all the third-party libraries that has been used in an application. Then we need to use some more advanced artificial intelligence-based tool in order to find the zero-day vulnerabilities, because this kind of vulnerabilities are maximum of organizations are getting affected of these vulnerabilities, and it's give them a very less time to just revert or to take any kind of action against it. And before to that only, the hackers do their work and they just take their complete data, or whether they just start with the ransomware kind of attack, or after doing an encryptions. Then securing all the public APIs that has been used in that applications, and using the automated remediations approach, which automatically making an applications more better in terms of cyber attack. Then the application security testing and orchestration. This is one of the newest approach, which the organizations, they seems like they will be definitely adopting it in the coming future. So these are some couple of ways, the previous ways and the new ways which organizations are following. And by that, definitely you can somehow you can make your applications less prone of getting a cyber attack. So that's all from my side. And if you have any questions, you can connect me over the LinkedIn or the Twitter. My username is Sapendra Dev, and I will be happy to take any further questions. Thank you, and thank you, American Digital Week.
So hi there. Hi. we changed our schedule for a little, so because we have a last minute surprise from Sam Stepanian. He's one of the developers of OWASP Hunter, Net Attacker. Yes, so this project is a OWASP project that is totally written in Python, and we have a talk that he has sent us.
Yes, so Netaka is a hacking tool. It's an OWASP project. It's been developed by the community over the years. It was firstly presented in 2018. I was happy enough to be part of this presentation at Black Hat with Sam. And Sam has created a presentation as part of OWASP for in California recently. And what we want to do is we're still setting the streaming app. We need about, I don't know, 30 seconds in real time. And we will, as we go into the coffee break, at the same time, we will let you enjoy a nice hacking tool talk. And we definitely believe for those who are not familiar with Netaka and they love infrastructure pen testing, you are going to find it very, very useful. It's amazing and fast when it comes to scanning, way faster than other tools. So give us, we're gonna go through the cinematic, and hopefully after that you will start seeing during the coffee break Sam's presentation on Netaka.
Yeah, and you will enjoy also your coffee.
Hi everyone, my name is Sam Stepanian. I'm an OWASP chapter leader and OWASP Netaka project co-leader. I work in London in the financial services sector as an application security consultant. Today I'm going to talk to you about the OWASP Netaka project. So a few more words about me. Apart from being an OWASP London chapter leader, I also lead the OWASP chapter committee, where we help all OWASP chapters to succeed, to be healthy, to be active. I originally come from the software development background. I'm an application developer, and I'm an application security guy, and I am a defender. So why am I presenting a talk about a tool which consists of two words, network and attacker, while I am a defender and an application security guy? I had a bit of a history with OWASP Netaka because I didn't know about this tool until I was pinged by the original Netaka project leaders in 2018, where they asked me and OWASP London chapter co-leader Dr. Greg Frakos to go to Black Hat Europe 2018 conference and present this project because the Netaka project leaders were unable to travel to London at that time. So myself and Dr. Greg Frakos, we had to learn this tool overnight on a Zoom session, and we absolutely loved it. We knew very little about this tool because it was a brand new tool back then. We saw it appearing on the list of OWASP projects, but we didn't really know what it is. And once we learned what it is, we were really happy to go and present it at Black Hat Europe 2018 in London. And then suddenly this happened. We had huge crowds of seasoned penetration testers, software developers, security engineers, even some information security managers gathering around our stand at the Black Hat Europe Arsenal booth, watching the presentation of the tool. So I said, okay, this is good. People like the tool. So I became a co-leader of OWASP Netaka project and proposed that it would be also presented the following year in 2019. And then suddenly this happened. Even bigger crowds gathered around watching this tool, and absolutely everybody loved this tool. But why? What is it about OWASP Netaka that everybody is so intrigued about? So OWASP Netaka, first of all, is an open source software tool, just like all OWASP projects. And OWASP Netaka's goal is to assist with penetration testing by automating tasks such as information gathering and vulnerability scanning. Because this tool is written in 100% Python, it doesn't require any external tools to be present on the operating system, and it can be run on Windows, Linux, or Mac OS. Very important thing to mention about OWASP Netaka, that it is actually written and enhanced by students who participated in initiative called Google Summer of Code. And if you don't know what Google Summer of Code is, it is a great initiative by Google, which is running every year. And that is essentially a paid internship for students to select an open source project of their liking and apply to work on that project during the summer break. And this is how we at OWASP benefited by having students to help us to enhance the tool. And actually, it's not just the OWASP Netaka. There are many other OWASP projects like OWASP Zap, for example, or OWASP Juice Shop, which benefited from Google Summer of Code. And it's not just OWASP which participates, many other open source organizations do as well. So if you're a student watching this, or you know any students who you think might be interested in spending their summer break working on open source and gathering some real experience, please do check out Google Summer of Code. It usually runs from March every year until the end of August. So what is OWASP Netaka? You can think of OWASP Netaka as a Swiss Army knife kind of tool, because just like a Swiss Army knife, it is a collection of tools. It has a modular structure. It's relatively easy to create your own modules. We recently changed how you write your modules from Python to YAML. I will talk about this a little bit later. It is a fast performing tool because it's using multi-threading, which you can control. It's using Python's multi-threading model. Important thing is that it has customizable profiles, which are bundles of modules focused on a specific task. So if you can imagine, you can pull out several blades out of your Swiss Army knife to perform a specific task to make it quicker or more efficient. And of course, the most important thing is automation, because you can automate and run this tool from the command line. So a few other bits about OWASP Netaka, that it is not an officially released tool yet. It's not even in beta. It's still in research and development phase. So the current versions are 002 and 003. And we're always looking for more contributors. I will tell you how to contribute to the project at the end of my presentation. However, what is great about OWASP Netaka, that it is usable right now. And it is a great tool which already has a command line interface, web user interface, an API, report generator. It also has Maltego transforms for people who use Maltego, which is a great investigation tool available, for example, in Kali Linux. And Netaka currently has over 70 modules. So you can find OWASP Netaka on the main OWASP.org website under projects. This is the URL where you can learn about the project and see some quick demonstration there. important bit about documentation, that we use the wiki part on the GitHub. So if you would like to read the documentation, please click on the wiki button once you visit the OWASP Netaka on GitHub. And there is an installation section there where you can learn how to install it. You can install Netaka relatively simply, and it will run on anything. So I prefer using it for using it in Kali Linux, but you can use it on any platform. There are several requirements for installation, so please do follow the installation instructions because there's some dependencies that you need to install. However, if you are using Black Arch Linux distribution, which is a Linux distribution specifically targeting penetration testing engagements, you will find out that recently Netaka was included in Black Arch, and you can see it's currently being listed under the Black Arch automation tools, and the version 002 is actually built into Black Arch, which is absolutely great. And we're very thankful to the Black Arch Linux team, which included our tool in the Linux distribution. So in order for you to understand what OWASP Netaka is and how it compares with other scanners that you might know, for example, with scanners such as Burp Suite or OWASP Zap. So scanners like Burp or OWASP Zap, they usually would scan one website for many web application vulnerabilities, and that's whatever the scanner is able to find. So these tools will go and crawl one website to discover all URLs, all parameters, all forms, all the buttons. Will try to click on all the links, and then it will try to see if there are any vulnerabilities. OWASP Netaka doesn't work like that. It doesn't scan just one website. It scans one or many, and that can be hundreds or thousands of IP addresses, networks, or subdomains. And what is it scanning them for? For open ports or one or more specific vulnerabilities listed by the user. And these are basically what our modules are. And you can bundle the modules in a profile to search for specific things. So Netaka consists of three types of modules. Modules of type scan, for example, port scan. Modules of type vuln, these are the modules which are looking for a specific vulnerability. For example, Apache Struts vuln module will look for Apache Struts vulnerability. And it has modules of type brute for brute forcing. So for example, an SSH brute module will perform brute forcing over the SSH protocol. So that's essentially what the module types are. And that's what makes this tool great, because it combines three different types of activities: scanning in information gathering, scanning for a specific vulnerability, and brute forcing. So how do you run Netaka? In order to run Netaka from the command line, you need to define two parameters. You need to define the target, what do you want to scan, and the module, which module do you want to use to scan it with. And you do it with the -i command line switch, where you define your target, and -m for your module. So for example, if I want to perform a port scan on IP address 192.168.1.149, I will call Netaka with -i and the IP address, and -m with the module with the port scan. You can also scan not just one IP address, but the whole network. For example, if you provide 192.168.1.0/24, you will scan the entire Class C network, or 255 IP addresses. And actually, Netaka has more targets available. You can scan a single IP address, as I've just shown you before. You can also scan an IP address range by providing a starting IP address and an ending IP address. You can also scan a network by providing the CIDR/bits notation. But what is also very interesting, that you can scan a domain, for example, owasp.org, and you can also scan URLs using HTTP or HTTPS protocol. So these are the various types of Netaka targets. But that is not all, because if you work for a large organization, that means you will have multitude of networks. You will have several domain names and lots of IP addresses. So what you can do, you can actually create a text file which lists all the targets that you want to scan, one target per line in the text file, and then just load the list of targets using the -l parameters. So that is another way of running Netaka. And again, for example, if you want to run a specific module, for example, a port scan on all your networks, all your domains and subdomains, that is what you can do. And this is what is making Netaka so great. So let me now do a quick live demo. Let me just switch to my Kali Linux installation here, where I already have Netaka installed. And again, a reminder, if you want to learn how to install Netaka, just check out documentation on GitHub under the GitHub wiki. So because Netaka is a tool written in Python, I'm going to use Python to run it. So if I run Netaka with no parameters, what is going to happen? It's just going to return a usage instructions. You can see there's lots of information being displayed on the screen, which can be quite confusing. This is why please do check out the documentation, where you will be able to find out about all the modules available, what they do, and any additional parameters that you might need to use. But here and in my first example, let me actually try to run Netaka on an IP address and perform a port scan. Actually, I want to scan this particular IP address now. So this is what I need to specify. I just need to provide the IP address and then port scan as the module. Of course, many of you probably using tools such as Nmap for port scanning, and usually people will have like a love and hate relationship with Nmap. And in Netaka, what is great about port scanning is that it is actually quite simple, very powerful, and it is written in Python. So you don't even need to install Nmap on your system. All you need to do is just to have Python installed. So there you go. You can see how quickly Netaka scanned it and returned us the results, where you can see all the port numbers which were open. And also you can see in the description column here, it tries to identify what they are. And you can see that it was Telnet, SSH, Sun RPC. But for example, you can see on ports 8084 and 8090 on this particular target, it thinks that it is actually running HTTP, which is very important because, as you can see, people can run things like web service or SSH service on some obscure ports, and Netaka can actually identify what is running there. You can see that the Netaka, after it completed the scan, it displays the information in its tabular format, and it also stores the data in HTML file, as you can see here, and the database. So the database bit is actually quite important because it's not like other tools which complete the scan and then that's it, and they have to do something with it. No, Netaka actually stores everything in database. And again, that is a very good feature because you can actually search a database, and I'll talk about this a little bit later. Now, we have seen how to use Netaka for port scanning, but let me show you some other ways how you can use Netaka by using multiple modules and how you can use it on a domain name. So for example, if I want to scan OWASP.org domain and I want to perform a subdomain scan, right, I can run this command, and OWASP Netaka now is going to go and discover all the subdomains of OWASP.org and give us the list. You can see how quickly this was done. However, what Netaka it has a unique feature which allows you to combine subdomain scan with any other module available. So for example, there is a module which is called server version vuln, and server version vuln is a module which is trying to detect if the web server in question is returning or leaking the type of the web server in the response headers in the server header. And we can see if we run it on OWASP.org that OWASP.org is actually leaking that its server header, and it says that it's running Cloudflare. So okay, great. Now we know what the OWASP.org is running on. But this is not all, because what we can also do, we can add another module. So I can change, for example, X powered by vulnerability, and that will return another header, which is the X powered by header, and you can also see any extra information provided by the X powered by header of that web server. And that is not all. As you can see, this is all on OWASP.org website, and we can see that Netaka actually discovered open ports, port 80, port 443, and told us in this information gathering session what type of the server and technologies are being run on OWASP.org. But what is great, as I mentioned, you can actually add subdomain scan to this, and by adding -s parameter, and what's going to happen now is Netaka is actually going to go and discover all the subdomains of OWASP.org, and it's going to run the these two modules that I listed on every single subdomain. And as a result, as you can see, it is very quick, and see literally within a few seconds, now we have information about all the subdomains of OWASP.org and everything that they are running. So this is absolutely great feature. And what you can do after this, because obviously, how do you consume the results? You can check out the report. So you can see, for example, here, the report is stored in the HTML file. So let's see if we can open this HTML file with a web browser. So I have a Firefox here. Let's see if we can open this file and see what is shown in this HTML file. You can see a great feature in Netaka here called penetration testing graph. And you can see that Netaka started its attack and started connecting to various subdomains of OWASP.org. And we can see that on every single target here, the server version vulnerability and X powered by vulnerability modules, they return a result. And you can see what was actually running on them. And why the graph is important, because by looking at the shape of the graph, you can see that and spot some patterns. For example, you can see that one of the subdomains of OWASP.org did not have X powered by vulnerability returning anything because that header was not present. You can see it was just server version vuln, and we can see in this case, this was Nginx. And if you scroll down of this report, you will find the results in the same familiar tabular format. You will see all the hosts, which will be either the subdomain or a specific IP address. If you scan your network, the username and password columns, which are currently blank, they are used for brute forcing. So if you try to run a brute forcing attack, for example, to discover if there are any servers on your network which are using default credentials such as admin or whatever default credentials you are looking for, they will be displayed here in this username and password columns if there is a match. You can see the port number, you can see the type of the module which was in use, and you can see the description column. There's a bit of a visual effect. So if I want to focus your attention on a particular line in this table, I can just hover over the row of data, and you can see that this particular host, for example, was running Nginx. So that is the results in HTML format. However, Netaka has ability to run some other reports as well. And again, what makes it great is that apart from the graphs, it can also output results in CSV and JSON formats. And why is it important? Because with using JSON, people can actually consume these results for integration with other tools, because JSON is structured data. And after you run Netaka on your networks, you can take that JSON file and feed it into any other tool which can consume it and, for example, provide you with different reporting, analytics, or perhaps further vulnerability scanning. And why is it important to have CSV? It's because you get results in a spreadsheet format. And this is probably what is so great about OWASP Netaka. It's probably the only tool I know which is free and open source, and it allows you to scan your network, discover all the open ports, all the servers, all the vulnerabilities, and then give you results in Excel spreadsheet format, which is fantastic. And everybody gets the spreadsheet. Everybody loves the spreadsheet. You can easily, of course, filter that spreadsheet, filter the data, search for whatever is needed, and it is absolutely fantastic for companies to basically run this free and open source tool and get the list of all the assets, open ports, and vulnerabilities in one very convenient spreadsheet format. So this is a unique feature of Netaka, which I think probably one of the best features of this little tool. What Netaka is solving by storing the results in the database format and giving you the spreadsheet, it's solving something called OWASP A0. If you don't know what OWASP A0 is, it's something that Jeremiah Grossman, the veteran of our application security industry, suggested a few years ago when we were due to release OWASP Top 10 2017. And the top suggestion from Jeremiah was to include A0 or asset inventory, because these days the biggest application security risk are websites that you don't know you own. Why? Because if you don't know what you own, you cannot possibly secure it. And Netaka solves this challenge for you because it allows you to create your asset inventory by scanning your network and scanning your assets. And of course, the recommended way of using Netaka is to use it on your own network, but you can also use it for penetration testing engagements or for bug bounty work where you can attack somebody else's network. But of course, always make sure that you have permission to do that. So some of the Netaka use cases, you can use it for asset discovery. So you can scan your network for open ports. You can scan networks for new hosts. You can scan network for default credentials. For example, admin. If you use brute forcing, you can quickly scan the network and find out if there are any service with default credentials configured on it. You can scan your network for a specific vulnerability. For example, a big vulnerability this year has been Microsoft Exchange SSRF CVE, which affected thousands and thousands of organizations worldwide. And we have a free and open source tool called OWASP Netaka with a module which actually allows you to scan all your networks and discover vulnerable service. You can also discover subdomains and open ports on them. You can discover things like expired SSL certificates in your IP ranges. Why is it important? Because if you have service with expired SSL sets, that means that the service probably abandoned and probably not patched. You can also find subdomains hosting vulnerable versions of content management systems such as WordPress, Drupal, and Joomla. And of course, what is important that you can run any Netaka modules on all subdomains of a specific domain. You can automate Netaka using the command line, and you get results using CSV, JSON, and HTML format. You can use it in Docker in your organization. When you spin it up in Docker, it will actually use the web UI or the API mode, and you can search for previous scan results and discovered assets in the database. That's what makes it great. I have a slide here which shows quickly what the OWASP web UI looks like. It's quite simple, and you can see different colors because different modules are color coded, and you can see that the brute forcing modules are orange, the vulnerability scanning modules are red, and the scanning modules are green. So when you select a particular profile, for example, all vulnerability scanning modules selected here, they will all be ticked and they will all be used. Important thing about the modules is that in the latest version of Netaka 003, the modules are written in YAML, which means that it is very simple to write new modules and contribute new modules. Please definitely do check out this new feature. The latest version is a little bit unstable yet, so we're still working on it. But the fact that it's using YAML actually will allow the project to respond quickly to the new vulnerabilities and release new modules, allowing you to scan for these vulnerabilities in your network. Just like all of us projects, it is open source, so we welcome contributions. If you want to contribute, please do check out the developer wiki, which is available on the documentation page. Do read and follow the contributor guidelines. And if you know Python, you can, of course, help us with coding. If you know YAML, you can help us with the vulnerability modules. You can also help us with translations and documentation if you want to contribute in a non-technical way. So that's it about Netaka. Please use it to attack your own network before the real attackers do. I'm now ready to take any questions. As you have heard from the moderators, we're taking questions today in OWASP Slack channel, and the current OWASP Slack channel for this track is 20th anniversary temporal. You can also contact me via email or via Twitter at SecureStep9. Thank you.
Hello, hello. Welcome back to our regular schedule. I really hope you enjoyed this surprise guest talk by Sam about Netaka. It's a very, very interesting tool. If you don't have it in your arsenal, I definitely recommend giving it a try. It might be helpful in many cases. It tends to be way much faster when you want to scan large C-class networks or wide range of IP addresses. We are moving on with our regular schedule to our next talk. We will also open soon, before the end of the conference, our Form B for those who need to sign for getting the certificate of attendance. So enjoy the next talk. Keep any discussions in the Discord channel, or if you have any questions, let the speakers know, and we'll take it from there. So, enjoy the next talk.
Hello everyone, my name is Konstantinos Statsakis and I'm here together with my good student and friend George Karadzas in order to present you our work on phishing, with our work entitled Phishing with is a hack recreation of an old attack on more or less new mediums and with more attack vectors. George?
Hello, my name is George Karantzas. I am a student of Professor Patsakis. I also work right now in the security industry, and this is a previous work of ours during my stay at the Athena Research Center.
Next. So, as George stated before, this is previous work that finished a few months ago, practically on April 2022. It's mainly funded by two EU projects, CyberSec Europe and Local. What we point out here is just our personal views on these matters. Have nothing to do with either the Commission or any current employers of the people who were in the research. Next. So, let's describe the main motivation and more or less the idea of what we are doing here. So practically, as many of you might know, there was a famous security incident that was made from someone who coined the name Phineas Fisher. Practically, what he did is that he created a zero-day exploit for some service, scanned the internet in order to find which are, let's say, the available and vulnerable endpoints that used this service, and tried to penetrate them. During this course, he managed to penetrate a web bank from Cayman Islands, and hacking his way in, he provided all the details of what he did, how he did it. The very concept is that practically we have the details from the attacker side, not from the analysis, of how a financial institution is actually viewed in the eyes of the attacker. And nevertheless, this is rather old. What we wanted to do is that given the current threat landscape, is to try to find ways to create this experiment in terms of new C2 servers, in terms of new attacking methods, however, also to try to stress test the defensive mechanisms that current critical infrastructure or current, let's say, financial institution would use. Next.
Prior to continuing, it's worth noting that in this case, we will try to, instead of using an external facing asset like the Sonic Wall VPN that Phineas Fisher used and exploit for, we will move to more realistic things, as we will see later, and also that in a malware testing lab, it's not always effective simulating user activity, which will give an attacker places to hide, things to hijack, and also a false positive rate, so which he can blend with. So this is something we can keep in mind, that in a malware testing lab, malware will always stand out and give the defenses some kind of advantage. So
practically, as we said, we were trying to recreate the environment, so-called Sherwood, that Phineas Fisher actually detailed in a more, let's say, recent environment. Here in the diagram, you can see more or less the network setup that we used. It's all recreated using VMs. Practically, you can see that we have a pfSense in order to more or less provide some segmentation to the network. You can see that in the endpoints we have used Sentinel-1 and 40 EDR. The idea here is that we try to create a heterogeneous environment where different machines are protected with different security mechanisms, so that it's more difficult for an attacker to hop from one machine to the other. So the idea is that we have positioned a Citrix server in a restricted zone to allow access only to the job server, more or less to recreate how things would be in a bank's secure zone. George?
So yes, we use the Hyper-V server to host everything. Here you can see more or less the zones, the work zone, the secure zone, which contains the Citrix XenApp, and the jump server. We try to make things look as realistic as possible network-wise. We would have to go from here to the jump zone to the Citrix server. And also we use some things like ClamAV on Squid to filter basic network traffic, blah, blah. So it's just, we focus more on the endpoints to this extent. So let me present to you the offensive capabilities we had. If you read the articles of Phineas Fisher, you will see that he was mainly using things like partial empire, Meterpreter, things that are out there. So modern APTs and offenders in general will use some kind of command and control means. Things will not always, there are scenarios where you can use like already existing assets, but you will always need some kind of malware to ease your way in and do things. And so we chose 5 diverse yet highly promising malware that are used but are not that are private and proprietary and not out there for everyone. So we will start by presenting Nighthawk. It's the work of MDSec, one of the top security firms at this moment. It's a hardcore red team toolkit from hardcore red teamers for hardcore red teamers. Stealth, configurability, and feature richness is in mind, but the main point that makes always Nighthawk stand out is basically there are 2 points: private research that is applied by the people at MDSec and as features, and also the malleability. This means that this is a highly a malware that can use highly diverse techniques to evade detection. You can always attribute a specific pattern to it because there are many ways in it to do things. There are some techniques that some of them are being slowly published by the team, some are kept in private. You can spoof things like ATW, TI, instrumentation, which takes place in NTOS kernel, which it's very hard to avoid. And spoofing strategies for mini filter callbacks, which is also driver related technology AVs use. The basic driver technology AVs will use. They will have a mini filter with kernel callbacks to monitor operating system events. So some of the features that we actually used and had the chance to test and do our work with was the ROP-based system call unhooking, and later full DLL unhooking stealth feature and other stealth features. It will make the operator's life easier by cleansing the process and reducing API-based IOCs that will occur from tools you run, because we need to separate IOCs that are related to the C2 and those that are related to the tools. If I run, let's say, safety CADs, this will have all the IOCs of loading mimicads and also accessing ELSAs, regardless of my C2, and this will get caught. So there are things that you will try to do. This applies to user mode protections mostly. There is also thread stack spoofing, trying to evade thread analysis and what the thread did, and in memory hiding while sleeping, trying to disguise in memory Nighthawk so that it will evade scanners. There are some customized process injection methods and some process injection methods that you can use, but are like OPSEC boosted, let's say, in some cases. So that, as we will see later, we want to blend in, and also network and callback related features for undercover beaconing. You can use themes, you can use like custom templates, you can use many means of transfer. So we will now talk about BruteRat LC4. It was created by Dark Vortex, and more specifically, an experienced operator. It's a low-cost alternative to Cobalt Strike, and it's supposed to be lesser known, more effective, and more stealthy. Some of the features include customized reflective loaders, some BOF files, beacon object files that will execute after some memory allocation, that will execute in memory, LDAP Sentinel for enumeration, easily configurable TTPs through the malleable profiles of it and the settings. Thing is, this product was not the most stable we have seen. We had several issues with it. The delivery methods were limited. So when you load something dynamically, there are more chances of it to get caught, especially in the case of those specific two EDRs we had that have some very intriguing, let's say, methods to target shellcode itself. And we tried to spoof that. In some cases, it worked. In some cases, it didn't. But we will see that this C2's function will be highly dependent on the environment and the endpoint. For example, if there is an in-process client, because we had things like sometimes an infinite loop, or we had like we tried to turn the solution into passive mode and see what gets caught and when and where. In general, we had some functionality issues, but the main idea is that basic task can be performed. However, even though we got a foothold, the way in some cases things were performed, it would trigger the ADRs on post-exploitation. And this is something we need to keep in mind, that, okay, we got a foothold. What do we do next? How do we do it? What is our context and how are we secure? Did we raise the score for some reason, etc.? So we need, unfortunately, we didn't manage to complete the scenario with this one. And we learned things because we had diverse ways. We had like many ways the ADRs would detect for different things of this tool and on access in some cases, or as I told you, after some post-exploitation task. But we need to keep in mind that we need adaptability, a holistic approach towards OPSEC and kill chains, and stability. This is something an operator wouldn't be able to afford to lose in a real bank, or raising the alarm, as we will see later, which could mess the operation. So Cobalt Strike, the most well-known, much work done from the community, many features. Now the latest version at the experiments time was 4.4. Now Cobalt Strike, we have to say that they do some great work on pushing updates, and also some things were changed in general in help system. So we see a lot of potential to becoming again the top, but it's still the norm for threat actors and red teamers out there. However, we wanted to break the norm by exploring alternatives. In this case, we have now user-defined reflective loaders, BOFs, reflective DLLs. We have various kits, which we didn't use to a great extent because, as you will see later, basically on touch, on access, Cobalt Strike was killed by many traps of the ADRs, either format-wise because of the shellcode, either behavior-wise. It was not something. It's something that the companies invested a lot into. And there are many ways to do this behaviorally, from emulation, many things, memory inspection. And we tried other EDRs apart from the two we tested above, and we saw that if we didn't do much work on our own, or we didn't use some kind of stage zero, or we didn't use some very specific configuration or loader specific methods, and have a good OPSEC wise logic, we would get caught by other EDRs as well that are not so known, some of them. Based on network stuff like network inspection and beaconing patterns, like many things, like memory scanning, behavior such as loading DLLs, etc. So as you can see, we can try to avoid some IOCs, but it's mostly up to the operator. And in this case, we will see a research from Sophos in 2021, and Cobalt Strike, out of 405 tools observed, it represented the 7% of it. So it's a rather interesting statistic, this one. So no, this is not a blue screen. In our case, those features of Cobalt Strike, like the kits, etc., were not very helpful. But I already described what we wanted. But what I have to say is that Cobalt Strike is also much, let's say, configurable. And if you there was an interesting article out there showing that if you sideload Cobalt Strike into teams and also make the network behavior look similar to teams, you would be able to evade some kind of inspection. So Cobalt Strike is a high quality product, but unfortunately at this time, it wasn't what we wanted and what we needed. And sometimes about the tools that are out there, there are very skilled coders, very skilled red teamers, but in our case, sometimes tools out there are not developed full-time by a company, so this is something to keep in mind. So Havoc was created by a personal friend of mine. It represents the other or unknown threats, and in my opinion, it's a very ambitious and very well-designed code-wise attempt. We had some generic issues because this solution was created for the most of the EDRs and not our niche thread landscape. We helped Paul as a team. We assisted in the development process, and we created some generic EDR and OPSEC safety related features, and we were able, although the communications were limited, now they're not because new beaconing options were added, but at the time it was still at beta. Same went for Nighthawk. And we tried as much as we could to make this solution adaptable. And we managed actually to use a solution that's like you see in the movies, a young person with a hoodie coding in the dark, etc. This managed to work really well, and we managed to complete, although with some more effort and some more trial and error and digging into the internals of stuff, we managed to operate. And this is some of the very interesting points of this research. So Oyaban was a stage 0. What this means is that it will make just some basic recon and execution tasks. There was like ngrok integration, Go native, reverse shell. It used TCP dialer and Go's way to execute system commands, which was very helpful. Keylogging and discovery features. It's not 100% stable always, but because it's a new product as well, but the team tries as much as possible, and we have had like a significant amount of effort and growth in terms of product, I mean as technology and improvement and learning with the team. So it's a very interesting product. They try to make it more and more stable. They will change the code base soon, from what I know. Thing is, it's just a static and staged binary. It may be limiting at some points. You can turn it into shellcode if you like, with some kind of recreation of Bootstrap reflective loader, but this will be unrelated at this moment. We managed, due to this nature, to do things. And we will proceed to the next slide. Professor? Professor, we can't hear you.
Sorry. The nice casualties that we have from streaming and from online meetings. So there are several differences compared to, let's say, casual engagements. First, we have to note that we have two different solutions that are working rather differently. So the case of unhooking is not always an option in order to evade the defense mechanism. So, for example, Fortinet is based on memory patterns and kernel-based filtering. So practically unhooking is not that easy. And in the case of Sentinel-1, it also has some generic hooking mechanism for in the kernel. Nevertheless, it also tries to find low-hanging fruits in the case of typical bypasses that an adversary would try to make. But also, let's say, through the star rules that it has, tries to find many bypasses. Here, in the environment that we have recreated, it is worth it to note that one mistake is enough in order to showcase that an attack is has been launched. The idea is that currently, with all these mechanisms which are monitoring all these system requests, all these system calls, the network traffic, etc., operating in an OPSEC way is not that easy, Nevertheless, it's mandatory because it will immediately show that the attacker is doing something malicious. As I noted earlier, the environment that we have created is very diverse, meaning that each host has different endpoint security mechanisms. So practically, this means that whatever works in host A doesn't necessarily mean that will work on host B. So practically, this means that in every hop that you make inside in the network, you need more. You need to be more cautious because you need different tools and different methods. Something that was not pointed out is that, as we said, the experiments finished on April. Nevertheless, they took several months in order to be made, and the main reason is that we had engagement with several of these vendors in order to report issues, in order to report bugs, so that they will be patched and not make more or less a red, or not a red teamer, but an adversary guideline. Yeah, that, exactly. More or less a guideline of what to do when you are facing a financial institution and how to penetrate it. No, that was not the case. So we responsibly disclosed issues that we found so that the whole ecosystem is secure.
It's worth noting that the traps of both solutions are quite innovative, because in the case of Sentinel-1, there is a trap to cover a trap to cover a trap, and we had the chance to beta test many of those traps during this scenario before they were ready for production. And also in the case of FortiDR, we had the chance to also check stuff and see how the real-time memory structure inspection works. And it's not like casual scanning, it's how shellcode, for example, could be different than a valid PE, and if there would be like normal behaviors. So from how they look in memory, from those, there's a difference of how things will look in memory, and this is harder to avoid. So some of the basic TTPs are some XLL files, DLL files with a specific icon, which is very tempting to click, and a specific export that will launch specific code, customized injections like DLL hollowing, which will patch the address of entry point with some kind of shellcode, or we will try to blend several injection techniques or OPSEC safety techniques, like where we inject and what we inject and how do we do this. MSI files are well-known installer files. We can add actions that will include persistence, like adding registry keys, services, blah, blah, whatever this could mean. Execute commands, run our binaries, use it for DLL side loading, which we will mention later. Whether it's a loader or a static binary, it's a good way to blend in with an application. So privileged driver-based loading and vulnerable drive abuse. We try to abuse other exploitable drivers that may expose, for example, an IOCTL that we can take advantage of and do our execute our code through this driver, or impair the defenses. An example are anti-rootkit tools, which you can use, for example, to load a driver, do whatever you want to some extent in the system from the kernel level, disable the AV, maybe some shadowing, as there are in internet cafes. You can use such tools to evade shadowing and see the coin miners the employees have planted on the PCs. This is how I get my free coffee when I go to the internet cafe. So I never told anything about this. Snitches get stitches. But in any case, we tried to use customized vendor-specific spoofing and bug abuse techniques that things we would do from the architecture of the solution itself to turn it around and make the EDR hit itself. So credential theft, we could use drivers again, like WinPMM to dump the physical memory and parse it and get credentials, reflective loading and loading of tools, including CLR and PS, PowerShell tools and reflection are things that we tried to see how they would behave in such a scenario, where we load the CLR, what's the process. If it's Excel through an XLL, for example, it's easier because Excel will make network connection, which is better for coverage, and also it has the CLR loaded by default. So this is a quick meter mapping, Professor.
Yes, so practically we try to map here what we consider that has already been made by the attacker in green, and more or less in red we highlight what are the capabilities that we have developed in terms of resource development, initial access, execution, etc. I hope that this is readable because it's far too many things that are listed here. Okay. George.
Okay, yes, I will proceed. So this is the offensive scenario review. You can see some of the screenshots and proof of concepts. This is Sentinel-1's timelines, which are pretty cool, I guess. Same goes for Fortinet's forensics. They give you queries and you can attribute things to an actor, but in depth, like what did you find? What kind of attack did you find? How, if you find this kind of IOC, notify me about this. So here we can see a casual process injection with a new thread creation. We can see execution of tools through Nighthawk. We can see how the panel worked and how we managed to do some credential theft through keylogging and credential theft techniques in general, how we execute tools, and how we disabled the ADR. So here, CLR beacons, for example, were loaded in processes that indeed use such technology. This is a good, we need to take into account OPSEC. So if I want to beacon through WinHTTP, I will use a browser, for example, to inject into, because it would be abnormal loading this this tool, for example, this DLL inside another whatever process. So we need to be careful how we look both on the endpoint and on the network. There's diverse tooling. We use diverse tools to achieve the same things. We try to use the kernel as much as possible and do things like impairing the defenses, so we could then launch Cobalt Strike or use a driver to and exploit also an AV solution to, through a privileged scenario, to inject into processes, into the installing like a free AV from the internet, whatever, you will find many, and injecting into that protected process and try to avoid some of the traps this way of and some of the monitoring by other tools. And the anti-incident response is like things like in-memory masking of the Nighthawk presence and things. You will see that you will not always be able to find it through tools like Moneta, PaySave, or even some commercial tools. So this is the attack timeline. We got initial access very quickly from via email from a categorized domain we had. We tried to use MSI exec combined with run DLL32. We used Excel, we used sideloading into WhatsApp and injecting into that free AV. We also then dropped a shortcut which would trigger an authentication to our farmer WebDAV server to steal credentials. Then we would impersonate the user, do GPO abuse, use tools like stand-in, then make our user an admin, do all these sorts of Active Directory casual things, casual exploitation things. Then we try to laterally move through SOX proxies, and we tried to execute the payload from a share or like launching the payload in some way. We extracted credentials with the WIMP-IMM, as I told you before. We used casual things like sarpexec, WMI, or WinRM to move through boxes. We tried internal monologue without the registry modifications for NTLM downgrade. This comes to the things we need to do when we want to avoid some certain footprint and we want to control the actual footprint of our attacks and tools. So again, we tried to jump on the final server. We used the now fixed vendor specific bug, which would blind the specific context of processes for the solution. We didn't have to face 2FA. However, there are recent articles and older articles, even in Finesse Fisher, you can see that you can steal the authentication tokens and bypass this. And there are also tools you could use for something like phishing for that, like Modliska. It's not something that's undoable, but 2FA is always a good option to have. This control is out of scope. So what's next, Professor?
So practically, we have contacted both Sentinel-1 and Fortinet teams in order to notify them of, let's say, the important issues that we have found in the resolution. Whether this has to do with architectural misses, whether this has to do with bugs or issues that we found, misses in the detection, or let's say gaps in the storyline that they created. Practically, both teams have been quite responsive in patching their systems and providing patches to their customers so that they are more secure. So in few days, I believe that if not already, because we are currently discussing with Sentinel-1 in terms of providing a documentation of these experiments online. There will be an article on the, yeah, exactly, a co-authored article from me and George regarding this experiment, and will be hosted on their blog. There is also the possibility of finding a similar article from Fortinet. However, we are waiting for the response from the marketing team. So a big thanks to all the team from MDSec, to Dominic, Peter, Modexp, and Matthew. George?
And of course, my friends, Paul Ungur, he has a great future ahead, and the Red Code Labs team. Thank you for your patience. These are our contact details, and we hope to hear from you soon. Have a nice day.
Hi there, and welcome. Thank you all for having me here at BSides Athens. As virtual as it is, I hope that next year we'll be able to do this in person. So I'm Dave Lewis, and my talk today is security debt and running with scissors, and we'll get into what that means in just a second. So I've been in security now for the better part of 30 years, and I have done pretty much every role along the way up to and including being a CISO for a power company. And I have always been of a hacker mind when I got started back in 1983. I hate that I can say that. I was really having a good time, you know, duping video games, selling my kids in school, that sort of fun stuff. And, well, time has skipped ahead on us, as it always does. And now I'm a pretty much grizzled old gray beard and a rather frequent coffee drinker. And it's been interesting over the last couple of years during the course of the pandemic. I got into a couple of side ventures of being involved with a whiskey distillery as well as a soccer club here in Canada, and it's been really interesting to be able to try different things, even though we have been for a large part of it locked down. But now hopefully we are coming to a better place. I want to believe. I also would love it if this virus would just go away. So I am Canadian, so sorry about that. It is running joke here in Canada. And, we have to keep our wits about ourselves because, so many times we have issues that crop up and we often forget about the human element. So we have to be very cognizant that we are taking time to take care of our own mental health as well as those around us. So having a good laugh every once in a while doesn't hurt, because we have far too many soul-crushing meetings. And you know what? We have to be very cognizant of that, because there are better ways to do things. And over the course of the last couple of years, we've actually found that we can be very productive as security professionals in this climate. So that has been a real bonus in that regard. So I myself identify as a hacker, and that means that, most of the world is not a big fan of us. Hackers, quite literally for me, is a term of someone with an innate curiosity about how things work, how we can take them apart and put them back together again. And the criminal side of things is something that I refer to as the attacker. So we have to make sure that we are owning our own lingua franca, because otherwise the media will spin it for us. So back many years ago, I got my first apartment back many years ago. And the first thing I did after my folks drove off, and it was just my roommate and I, is I grabbed a pair of scissors and I ran around the apartment. And my roommate thought I had completely lost my mind, and he wasn't too far from the right. You get me. So I just thought it was an ultimate act of rebellion, not taking into account that this could have been a rather unfortunate accident if I had tripped. And this is really how I like to frame security debt. Now, for me, security debt is a technical debt that has manifested as a security issue, and we'll talk about that a little bit more later. And it is very much akin to running around with a pair of scissors in your hand. Seemed like a good idea at the time. So we have to make sure that we're looking at how we're doing security in our environment. And, just because something's inside your firewall doesn't mean it's necessarily secure. Because I have worked in an organization in the past where that was actually said to me by a CIO. And the problem here was that, security wasn't part of the equation. It was a flat network. And the phrase that was said to me was that we trust everyone who works here, which is all well and good because, ransomware trusts everybody too. They trust us to make mistakes. Ransomware really is the debt collector for security debt, and we have to make sure that we are not making it easier for attackers to be able to get their job done. Another thing here too is, we all like to be environmentally friendly, which is a good thing, except when it comes to passwords. Now, I stole this from my friend Karen Elzari, and you know what? This is a great idea here, because we have to make sure that we are not recycling passwords. We are not reusing them on multiple sites, from our internet banking to, whatever it happens to be, because the attackers know this and they will go after sites and compromise them and then reuse those credentials to try and escalate their privilege. So we got to make sure that we are not making their jobs any easier. Because as a security professional, we always feel like this, or at least I do, and hopefully we can get to a better place so we are not feeling like this constantly. So when we're born into this world, we have to understand that we are defaulting to trust. Now, Malcolm Gladwell talked about this in his book, Talking to Strangers, that when we're born in this world, we are looking for food, we are looking for shelter, we are looking to be safe. And as a result, we don't have an innate understanding as to what it means to be securing our environment and making sure that, attackers can't cause us undue harm. We are just reaching out and hoping for the best. Now, this does not translate into the modern world. And when I say that, from the perspective of computer security, we want to make sure that we are trust but verify and verify again, because we can't just accept at face value that someone is who they say they are. We have to make sure that trust is an absolute factor in everything we do, but it's established trust. Because trust is ephemeral. We want to make sure that we are not just saying, oh, I trust Frank because Frank is somebody I've always known. Because Frank might not be Frank behind the keyboard anymore. Frank might have lost control of his own credentials. So we have to always keep that in mind. Because in the last couple of years, we've really seen that our security paradigm has shifted. Our threats are different. I've been very fortunate that I've been a home office user for many years. So a lot of this was old hat for me, but too many people have, really had a hard time adjusting. Because before the pandemic, we had folks that would say, oh, I'm going to work from home on Friday, which was code for, I'm going off to the islands, or I'm going off to the cottage, or whatever it happens to be in your respective jurisdictions. And it has really changed how we view the world. So in addition to the threats that we have to deal with, cats running across keyboards, dogs chewing through cables, kids tapping on computers when they shouldn't, we have to make sure that we also understand the human element, as I mentioned before, because the human element really does factor into security debt as well, because we want to make sure that we're being aware that people are in a different environment. They are really trying very hard to get their jobs done in a safe and secure manner. And they're worried about, how are they going to be able to pay their bills? So, attackers know this, and they tend to prey on this using various phishing techniques and things to that effect. So we want to make sure that we're giving them tools that are going to help democratize security and keep them safe and secure at the same time. Because security debt, as I mentioned earlier, it's about for me, is a technological debt that is manifested as a security issue. And I really like to make that absolute distinction, because I have been in too many environments in the past where security debt really had become a wide open problem. OS2 warp systems running HVAC that were attached to the internet, all sorts of really odd things like that. An old Polycom device that was configured to access the internet using default credentials, and also with the ability to change that to allow SSH through it into the network. These are the kind of things that you might not think about at the time, but they do manifest as a security issue once the attackers find them. Absolutely, but we want to make sure that we're managing that risk to our environments. Because things like Heartbleed and Log4j, these are going to continue to happen. Because when organizations are using open source software, and to be clear, there's nothing wrong with the open source software, but they have to be able to manage the risk associated with it. Because at the time, Heartbleed's the SSL library was being used by e-commerce sites all over the planet. Like, everybody was using it. But at that point in time, there was about 1.5 people dedicated to maintaining that particular library. Thankfully, that has been remedied, and they are well financed and the rest of it, but it's just one example of many. There are all sorts of open source libraries that find their way into commercial software that may not be properly maintained. So we want to make sure that we are keeping on top of that and not introducing undue risk into our environment. Because there's different ways to handle risk. Do we avoid it, accept it, reduce, transfer? The thing here that really bothers me is far too often I see organizations just accept the risk. They sign it off and move on, and it's forgotten. That piece of paper ends up in a desk drawer, or it's filed off in some obscure part of your computer that you never look at again. And that's a problem, because there's also the piece, who is accepting that risk? Who has the ability to accept the risk in your organization? And what's your plan to deal with it in the future? Because things like this are going to continue to happen. I've seen this in far too many environments where a beige desktop was in production, running mission critical code written by a summer student that nobody knew how to port it off, and they couldn't afford to shut it down because it was running a critical function. This is just one example of many that far too many organizations have in their environments. Last couple of years, I've been doing CISO roundtables, roughly about one per week. And this has been a topic that has come up over and over again. These old deprecated systems that we're running that are not maintained, not patched, but it's okay because we have a firewall. It's an unfortunate notion that people put a little bit too much investment into the idea of a traditional perimeter. The castle wall, the moat, and all the rest of it. Really, that has been a deprecated notion for many, many years. We want to look at the access perimeter the perimeter is being anywhere an access decision is being made. And we have to be very clear on that. So just accepting the risk is not going to help you. It is going to buy you time, and it's usually driven out of a IT project. The project manager just wants to get to end of job, so they accept the risk, they move on, and the risk is forgotten. So this can't continue. Because when we're looking at it from a project-based perspective, there's usually no sunset provision for that particular project. So when that project is built, it could be meant to last for 3 years, 5 years, whatever it happens to be. But then in most organizations, it'll limp on for 10 to 20 years. And this is a real problem when they're not being patched, not being maintained, not being configured. The people who installed it didn't properly document it and have now left the company. These are the kind of things we have to make sure that we're keeping on top of on a consistent basis. And when you're looking at security in your environment, you want to understand what are those business priorities for your organization. Running around with your hair on fire saying, oh, this is really bad, has extremely limited utility. You want to look at it as, what are the outcomes you're trying to achieve from a security perspective in order to satisfy the aspirations of your business. Fundamentally, that's it at its core. So if you don't understand what it is you're securing in your business, you're not just saying, the answer is no. You're going to put yourself in a bit of a disadvantage. You want to make sure you clearly understand what the mission of your organization is so that you can best protect it. And from a business context, what is most important? What are they, like I was talking about, what are they trying to achieve? But we also have to make sure that, we're not negatively impacting systems or our environment. We have to be able to facilitate that conversation with the developers, with the business units, so that they don't just stand up an application and hope for the best. In the past, I was dealing with one organization who built out a web application and put it live, somehow bypassed security altogether. And the very first day it went live, they came to me and said, oh, we need a security review. Nothing like being timely. The problem here is the first thing I did was view source on the web page. And right there, commented out in the code, was the username and password for admin and password. I wish I was joking, but this was actually a thing. What was made it worse was the particular manager for that development team looked at me and said, "You've hacked our application." I had to take a moment's pause. That was a very difficult moment for me because I wanted to scream and pull my hair out, but that wouldn't have accomplished anything. I, at that moment, realized that there was a failure on my part and my team's part, that we didn't clearly communicate to the organization what we expected from them from a security perspective. And they clearly didn't have any understanding of that. So rather than vilifying the users, I had to find a way to have that conversation to better impart what security issues we needed to take care of so that this didn't continue in the future. Now, we talked about project managers and how sometimes you would see, risks being accepted by the wrong people. But, within your own business, ask yourself this question: who has the ability to accept risk? Typically, it ends up in the C-suite, but not every organization understands that. And far too often, I'll see organizations that are accepting risk that are individuals that have no capacity or authority to accept a risk. One organization that I was at, and I left shortly after this, was we had done an entire vulnerability assessment of the organization, found absolute plethora of organizational issues, vulnerabilities, configuration issues. Imagine a flat network that spans the globe. And we presented them to the head of IT, wasn't even the CIO, it was the IT manager, or director rather, for that particular part of the organization. And he said, that's okay, we'll just accept the risk. This was very, very difficult to wrap my head around at the time, because at no point was he doing anything to mitigate the issues. And it was really a trivial exercise for an attacker to breach that particular organization. I sincerely hope that they have long since fixed these issues, but it was not something that they were really keen to take a serious look at the time. So when you're looking at, the various security issues within your organizations, what those risks are, and when I say the risks, I mean it from quite literally an expectation of loss. If this particular system goes down, how much is that going to impact the business, and how is it going to impact the business? How can you quantify that, and how can you improve the process in order to make sure that those risks are being dealt with? So, do you have a risk register? Are you tracking these risks to end of job? Are you able to clearly communicate this to the auditors when they come calling? And wow, they come calling. Pardon me. Take a little water break. So we want to make sure that we have a clear, defined, repeatable process on how we can address this and reduce the risk in our organization fundamentally. Because if these risks are not addressed, over time they compound. And when you add in new systems, add in new projects, over time you end up with a layer of digital detritus that really can cause an unbelievable number of issues. And if an attacker is able to breach one system, all of a sudden they have the ability and capacity to pivot from one system to another. And we don't want to make their job any easier than it already is. We want to make sure that we are not allowing, these issues to languish. Because, fundamentally that danger does grow over time. And if we have a lack of action on our part, it just presents targets of opportunity, for the attacker. And when we layer in things like IoT, the risks explode. They are many and many, many issues that come with this. And I'm not talking just simply about consumer grade cruft of, the baby monitors and the wireless light bulbs and things like that. But, control systems that are being used to do manufacturing, to handle control systems for power, water, and so on. All of these things, if they are not properly maintained, we have a real problem. And there is an adversarial relationship that I've seen historically between OT and IT groups within organizations that handle these systems. We have to find a way to build that bridge to make sure that we're avoiding these security issues, because as these things crop up, they're going to add greater and greater levels of complexity for our systems that we need to protect. And we have to go through that lather, rinse, repeat. And as we add in multiple systems, that becomes far more difficult to address. We can't just be that flaming sword of justice that's running down the hall and saying, the answer is still no. And we have to make sure that when we make our slides that the color of the letters on the slide are the right color so you can actually read it, which it says the flaming sword of justice. So that refers to somebody that I knew many years ago who really his answer to everything was no. And this does nothing to improve security for an organization. That's an old school dated approach. And it's really ineffective. If we are not taking time to empower the organization to help them better understand how to secure the environment, it's doing nothing to improve matters. Because that perimeter is not what it used to be. It's everywhere. Anywhere an access decision is being made. Because data breaches are happening, and they're happening all the time. And it really does seem in a lot of cases like, everybody wants one. So we want to make sure that that is not going to continue as a trend. Back in 2012, I started tracking data breaches, and there was a few here and there. I think the biggest one at the time was 6.5 million records, which was pretty huge back then. But nowadays, we're dealing with orders of magnitude of billions of records being compromised. We can do better. When we look at it and we see that a lot of the breaches are handled, or rather facilitated through weak credentials like QWERTY, password123, things like that, vilifying the users isn't going to help. We have to give them better tools. We have to give them better ways to protect things. Because if it's a weak, unpatched device, that's on us. If it's a bad password, that's also on us. And I don't expect non-technical people to be computer savvy. So we want to give them something that is going to help protect their organization and make it as easy as possible for them to be safe and secure so they can, concentrate on their core competencies. Continuous trusted access is a great way to do this. I mean, some people say zero trust. I like it this way because a lot of times I've heard people spit on the floor when they say zero trust. Zero trust really is fundamentally about reducing risk. So if you say continuous trusted access, it's making sure that you're going through and approving all the users, devices, and applications on a continuous basis because, as I said, trust is ephemeral. This will help improve matters in the longer term. And you want to make sure that security is part of your mission overall. So just saying, you're one little security group running around terrorizing, people in your organization saying, do this or bad things will happen isn't going to help improve matters. We want to make sure that security, it becomes part of the fabric, the DNA fundamentally of your organization. Because as a security professional, I shouldn't have to exist. This should be part of the overall structure. But again, going back to when we're born into this world, as Malcolm Gladwell said, we default to trust. And we want to make sure that we are helping organizations to better understand this because, security people are a little different. We have to get away from the baling wire and duct tape approach to putting our systems together. We have to have clear strategies in order to get to that better place. And then we do that through having clear and concise planning. You want to trust but verify within your organization. You need to establish trust in your user identities, devices, applications. We got to sanitize our inputs and outputs for our applications. I mean, SQL injection has been on the OWASP top 10 since the beginning. It's still there. Still one of the absolute biggest ways for attackers to breach systems. And we have to make sure that we're patching things. We can't just be worried about, the 0 days. I'm more fundamentally worried about the 100-day, the 200-day vulnerability that hasn't been addressed. That database service pack that has not been applied for 3 years. These are the kind of things that keep me up at night. So if we go through it and we look at zero trust or continuous trusted access, however you want to call it, it's about reducing risks. So fundamentally, you want to go through, establish trust in user identities, evaluate the device, look at enforcing policies and make sure that, Dave from Canada is not suddenly showing up in Mykonos attaching to your systems when I'm not actually on that side of the planet. These are the kind of things you want to make sure you're on top of. Securing the connections to all of your applications, because you don't want me sitting at a coffee shop here in Canada accessing your email systems when I don't work for you. And you want to make sure that you're going through all of that data you're collecting and looking for anomalies, because they will continue to happen, because attackers are going to always be looking for ways to get into your systems. So here's a real quick flow. User requests access to an application. We establish trust on them using, say, multi-factor authentication or passwordless. These are ways to do a better job of authentication. Looking at the trustworthiness of the device. Is it running Windows ME? In my web logs for my own site, I have actually seen that recently. It wasn't it was Windows 98. Somebody was trying to access my website, and I'm sure that was a horrible user experience for them. Enforcing policies on user device combination. Make sure that Dave is in Canada, not in Mykonos or something, or Athens, for example. And making sure that you then build in a secure connection to the application. Once you've done all of that, go through and look for those anomalies. So if you take nothing else away from this talk today, I need you to go and look up WebAuthn. It is an open standard that really is about passwordless authentication. And this is a way to make it easier for the users to, access their systems. We want to make sure that we are making things that are going to democratize security, making it as easy as possible for people to get their jobs done. We've learned a lot of lessons along the way. The problem is putting those into action. We want to make sure that we are facilitating a better conversation, because as security practitioners, we have really gotten to that place where we are now at the adults table. We're being taken seriously. So we have to make sure that we capitalize on that opportunity to better secure the environment by being a champion for the environment of our organizations to better secure them. There are a lot of problems out there, and we got to make sure that we're not worried about the sharks that are patrolling the waters. We got to look at the ocean. The ocean is really the bigger threat and often overlooked. We want to make sure that we're building a safe and secure future, and you're using multi-factor authentication, using passwordless, making sure that you are reducing security debt in your environment are all ways to better improve things, because we don't need to cause ourselves problems. We got enough of them to contend with as it is. Thank you very much for having me, BSides Athens. Hopefully I'll be able to do this in person in the future. If you want to drop me an email at gattaca@cisco.com or find me on Twitter at Gattaca. It is truly an honor to be able to be part of this again today. And thank you, and see you all later. Bye.
Hello. Sorry for that few seconds of black screen. I think we are about to conclude the event for this year. Hope you guys, everybody on this trip, enjoyed it as much as we did. It takes a lot of effort and a lot of volunteering to get things done in order to be able to see what you see. It's very difficult for us creating a virtual event because some things are not as easy to control compared to an in-person event. As you can see, I have also Olga with me again right now. So the first thing, line of business, will be to give you the form for the CPEs, as we said earlier on. Olga?
So, we trust that those of you who joined us from the beginning today are have already filled in the first part of the form so that you can collect the CPEs, those of you who need them. We'll make the second form available now, so please just fill it in, submit it, so as a result you'll be able to get your certificates.
You should be able to see the information on your screen, and we will also copy the URL onto Discord.
Yes, it is available. You can see the form, the form link on top of us now.
Yeah.
So, second thing is that, as always, we are looking for sponsors, and we are already planning for a bigger and brighter event for next year. We very much hope that things will be back to normal, and we very much hope that we'll be able to meet you all in person next year. So, as a result, to make the event as bright as we would like it to be, we need sponsors and we need volunteers. So if you either want to volunteer and help us out, or if you wish to refer a sponsor or introduce a sponsorship for us, or if you want to introduce us to any sponsors, please reach out as soon as possible. The email accounts that we are using are available on our website, so at any point that you may have any ideas, we are open and we'll be waiting to hear from you.
Please keep in mind, it's not about only providing funds when if you want to sponsor BSides, as we've done in the past as well. We're open to any ideas that you might have. We had sponsoring with cases of energy drinks. We had people sponsoring venue. We had people sponsoring with tickets, gadgets, swag, anything that comes to mind. So we're open to ideas. One of the things that we have in mind is to find a sponsor who will be providing sustainable, reusable cups, coffee mugs, or whatever you want to call them, to give them out to the people who will be attending next year's event. As Olga mentioned, we are looking into making it bigger and better. And that means investing a lot of time trying to get things done. And of course, this is one of the things with the security BSides in Athens, is that we are keep reaching out to the community to have people getting involved, getting engaged with the community, trying to take upon responsibilities and do things. We are already, believe it or not, about 10 to 15 people here and there who are every year in what way or another try to help us put this event together. It's not an easy job when you have a day job and you have many things to do.
And let's just not forget our community sponsors, because having people from the community supporting us and supporting the effort, either by helping out to reach out the wider community, or to support us on media and several different communication channels, that is also enough sometimes.
Again, for those who might have missed it up to this point, the form for the CPEs that you need to sign, the second form, is available on the Discord channel, the URL, so please don't forget to do it. It's going to be open for another, I think, 10 minutes or so. So that's the message at the moment from us.
Yes.
Any other things that we need to mention is...
We are waiting for input from you, so we would be very excited
To hear from you.
To hear from you. So any input, any people that you think that would be worth inviting to give a talk at BSides, any people that you feel that you want us to reach out and invite them. Of course, the CFP form will be open in a few months' time, and the whole idea is going to be for you, for the whole of the for the international BSides community to offer us to submit their talks. But still, as audience, if you feel that you want us to reach out to
as we said earlier on, we said earlier on Discord, the hot topic that we're discussing is let us know who are the people would you like us to bring in Athens that you might admire, or you might to see their work, or you want to speak with them in person. Internationally, I would say internationally renowned hackers, from the point of view that these are people who are doing red team engagements or writing tools or writing hacking tools. Let us know who you would like us to bring in Athens, and as we have done repeatedly in the past, we have brought very important people to get to meet them in person and get to know them. We will do that. We will get them on board and we will bring them over. Of course, it's not only about hackers and ethical hackers, any other professionals that you believe that we would benefit as a community in Greece to get to see them and get to know them in person. Reach out to us, let us know. We'll put also some kind of a form on Twitter in the next few months. We gather the names, and the idea for now, but this can change, is like the top 5 people that everybody agrees. We'll try to reach out to them and get them over to give us talk.
These can be independent researchers, can be industry experts or specialists. I don't really like the word experts, but specialist is a more rounded word, or academics as well. We can invite anyone. And
any other business.
The plan for next year, that what we were discussing earlier about having different tracks. Perhaps you want to refer to that.
That's the other thing, that given that we want to invite all these people and we want to give you the stage to come and present, if there are enough talks that needs to present it in some people want to present in Greek, it's something that we can consider. However, what we want to do is to create a dark stage where we have hacking talks separate to the mainstream. Again, this is because we're going again back to in-person events, hopefully. So that will be a great additional. Imagine something between an arsenal stage and a dark stage of hacking talks, hacking tools, and all that. So we want to do that as well. If you want to volunteer for the event or during the year to help us out, build the event, make it better, make it bigger, please do reach out to us. That's how the community works. I know that in Greece, even though we have tried tremendously over the years to expand the volunteering efforts, it's something that it's not that easy to do compared to what we've seen in the rest of the Europe, at least. And if you are around, if you are in Athens, if you are feeling that you want to meet us in person this afternoon after Siok Sok Sok, we will be in nearby mini cafe, bar kind of thing. Funny enough, we didn't know about it, but it's called BSide. I have here the information where I can put it online for all of you to see. So this is called BSide, and it is very close to the Vios center where we are streaming at the moment. So if you want to come join us, we will also post the map pin on Discord of where this is. So if you want to have a chat, come and meet us, get involved, get engaged with us. We're happy to meet you. We're happy to have a chat with you. We're happy to get to know you. Anything else?
BSides is going to B-side for a refreshment.
For our favorite beverage in a mega pint. That's all for now. We will put the map on the Discord. And I think we
That's
we
it.
need to close
Yeah.
our event for this year. Thank you so much for attending. Thank you for watching. Last year, online streaming over the year reached about I think 1,000 something views plus the individual talks. We'll put everything online. You'll find everything on YouTube. Anything else, let us know. Reach out to us. Thank you so much for being here.
Thank you for being with us again this year, and we're very, very much looking forward to meet you in person next year. Of course, this way, we can have audience from all around the world. We'll be in person, but we will try to make it bigger so you won't miss out if you want to join us.
Excellent. Thank you so much.
Thank
Take
you.
care.
Take care.
Have a good afternoon. And we'll see you next year. Thank you so much. Thank you.
Thank you. Bye.